studied what is the necessity of SFD BMD, comparison between the beam and the shaft you have studied. Next you have studied the types of beams you have studied. Then you have taken one example on the simply supported beam subjected to 3 constant point loads. Now we are going to discuss some more example. Yesterday you made so many conclusions, you made it. Yesterday night I sent my conclusions to the MIDI team. I hope they might have already uploaded SFD BMD conclusions and summary table of strain energy. Other one is theories of failure and deflection of the beam table. For SFD BMD around 36 conclusions was uploaded. It is my handwritten copy. And theories of failure summary table, it is also uploaded. It is also my handwritten copy. And the remaining, the strain energy summary table as well as deflection of the beams, that I have not written, but I taken a copy from one of the student who is recently I completed the offline batch now, because that's the first time I drawn it in the class. So I taken a copy, and that copy is what now shared to you. Have you gone through this all this now? SFD BMD conclusions, around 35 36 conclusions was there. Next, summary table of the strain energy, and everyone is there. SM Krishna's table is there now. Then deflection of the beams. In deflection of the beam table, we are having the for different beams. I written the maximum shear force value equation expression. Maximum bending moment expression is written. C1 and C2. C1 is the constant for the slope. C2 the constant for deflection. Then I written the theta max equation. Theta is about the slope. And Y max the deflection. Y max the deflection. Then you have drawn the SFD BMD was drawn. SFD BMD was drawn. So can anybody confirm now whether have you seen this? Have you whether these conclusions are uploaded in the app or not? Please tell me what now. First year what now? More circle you can write down now. First you tell me, I'm asking what now, whether conclusions are uploaded or not, means sir please upload the more circle conclusion. Please give me answer now. Whether have you, please confirm me whether all these 4 conclusions are uploaded or not. Have you seen all this thing now? SFD BMD conclusions. Second one is going to be summary table of the strain energy. Third one is going to be maximum slope, maximum deflection, maximum shear force and maximum bending moment expression table. Other one is the theories of failure summary table. Sir, conclusions not have uploaded. Okay. Okay. So those who have not gone through that, probably yesterday night I sent it to them around 9 o'clock. They told that what now they are uploaded, because maybe server may be busy, some technical is going to be there, they have to upload it, then mapping and everything is going to be there. It may take, I thought that it is going to be uploaded by today morning. So check it during the break time or after the end of the class today, can check it. One suggestion, please, it is my request. All these conclusions, it is based upon my 27 years of experience. I have prepared that conclusions only for the students who is attending my lectures now. It is not from any of the textbook. It is not any of the text. That all the conclusions are going to be indicates my 27 years of experience. My request is, please don't, if you are going to make a copy of that now, please don't share that conclusion to anyone. Sir, my friend is there, sir. If you are going to send it to any of your friend, he will have so many friends. So that will spread like anything now. That will spread like anything. Spread like anything. Be selfish. My experience and my conclusions should be with that one, only my students should get benefited. And if you are going to send it to your close friend, he will have a close friend. So already mentioned, he will share it in once it is went to your social media, that will be more powerful than coronavirus. Probably I've already mentioned now. Be selfish. Please don't share it to any of the batch. Probably first time I've shared. Last year also I not shared any of the prime batches, because the prime batches, some students are going to be share it to some of the students now. They will make a copy of that one. They will share it to some of the students now. Generally offline batches I used to copy. They will make a copy. I'm going to keep a copy in photocopy. They will make a copy of that now. Once again, please try to understand. Be selfish. Be selfish. This is my experience, as well as what now? You have paid the tuition fee and you are spending so much of time. So you should only yourself should be get benefited. I hope you are understanding what I am telling now. If you are going to share it to somebody, I am not going to be the loser, because I am creating, still I am going to upload it, I am going to change it now. Some students are asking, sir, why don't you publish a textbook on strength of material? If I'm with all these conclusions, if I'm going to publish a book, this will goes to each and every one, not only middle students now. Every student, the textbook they will purchase with 300 or 400, whatever it is now. Nowadays, 300, 400 rupees, that is, but my 27 years of experience is there now, and that goes to everyone, each and everyone. So my information, my experience, with that one only my students should get benefited. That's the reason I am not gone for any publication of all this thing. Please try to understand. Recently, so just now I got a confirmation from the Medidi team. It is already uploaded. From Hyderabad team, they are already uploaded. But finally the mapping is going to be done, should be done by the Delhi team. So by today 10 o'clock, but mostly by afternoon. So you can see that all that conclusions. But today afternoon when I'm giving the lunch break, so today I forgot to inform, today class will be up to 5 o'clock, 8 to 12:30 and 1:30 to 5 o'clock. Anyway, you are attending from 3:30. Means almost 7 hours your class attending, only 1 hour extra, 8 to 12:30, that is a 4.5 hour lecture, and 1:30 to 5, 3.5 hours. So we are going to get the 8 hours lecture, you are going to get it now. So today onwards, that is Friday, Saturday, Sunday and Monday, These 4 days, you will have the minimum of 8 and hours class is going to be there. But today you are going to be up to 5 o'clock. So I'm giving a 1 hour break. Anyway, yesterday you are attending the class up to 12:20. So only 10 minutes more. Then you can have your lunch. And you can relax for 15-20 minutes. And once again you are going to join the session after 1 hour break now. So during that break time, you can go through it. Mostly by afternoon, it will be, you can see all these conclusions. Recently, I completed evening English batch now. The students was requested so many times now, but still I not uploaded. Because here so many students are having so much of interest. I have seen so many of the students are interested. I found so many students are what now focused. So then I want to help them now. That's why I uploaded all the conclusory app now. And one more thing, the theories of failure tabular form. I'm going to give the theories of failure tabular form. 1 page. When you are going for any examination, you can ref the theories of failure table. That's all. That is for revision now. Total theories of failure questions, you can do it from the table. Each and every equation will be there. They are not from any of the textbooks now. So that table is sufficient for you when you want to revise the theories of failure just before the exam, the table. Similarly, SFD, BMD conclusion, you need not, if you want you can write down, but otherwise each and every conclusion is available. Now, regarding the number of vertical lines, height of the vertical line will give the magnitude of the constant point, or like that yesterday whatever you have discussed now. Each and every conclusion is available now. Next, deflection of the beam page now, table. That is going to be, if you can remember the table, by heart that now. Today itself, all of you what now? Tomorrow mostly we are going to start with the deflection of the beam. Maybe after morning, after maybe afternoon session, we'll start the deflection of the beams now. For that one, all of you what now? Please, you have to by heart that constant C1, C2. Slope is inversely proportional to C1. Ymax inversely proportional to C2. So if you can remember that constant, then only you can complete the questions within a less time. 70 to 80% of the objective questions are both GATE and ESC. 70 to 80% of the GATE and ESC objective questions directly can do it from the table. From the GATE examination, there are 3 questions directly asked from the table now. Directly they asked now. And not included everything, whatever is required for examination and whatever required for the mechanical engineers. And the table is also useful in here when you are doing the vibrations, transverse vibration. When you are finding out the maximum stress, maximum bending stress, you need a maximum bending moment. So directly I have given the maximum bending moment equation now. When you are finding out the maximum shear stress, we need a maximum shear force. That also written now. And you want to find out the maximum deflection. Maximum deflection WLQ by C2 into EI. So that C2 value, if you can remember it now, that is sufficient now. So that table will be what a very, very useful now. Next, other one is summary of the strain energy table now. Summary of the strain energy. The strain energy summary table now. If you can go through on that now, that will be what now, you will realize that what is the importance of that now. Not only conclusion, even if your class notes also, not, don't try to share anyone. Sir, my friend is there now. You will have so many friends. First of all, be selfish towards your goal. If you want to get a success, always what? Some cases we need a selfishness required, not everywhere now. But for your success, you should be selfish. If you are going to create a competitor for you, now definitely what now? He may get a success now. He may get a better rank now without spending any tuition fee, without attending a single lecture. You will get it. And you will share to indirectly what now? You are spoiling them now. Okay. So I already mentioned today the class is going to be not almost 8:20, around 12:30 or 12:40 based upon the question or like that. We are going to give a break. Then with a 1 hour break, we'll discuss. Don't feel it. Sir, 8 hours of class now. Anyway, you are every day. Your official class is 6 hours. Anyway, you are taking up to 7 hours. Only 1 hour is going to be extra. If you have anybody having sir, it is not acceptable to us. Definitely, I will complete the syllabus within the given time. So try to complete our syllabus within the given time. 2 o'clock you close it, because our official times are 8 to 2. After 2 o'clock we will not attend. Complete the syllabus 2 o'clock. If majority of the students are not acceptable for this now, majority, not 1 or 2. If majority of the students are having any inconvenience attending this now, definitely I will modify my lecture as per the available time. I will complete it. Completion is what a very, very easy now. So return the next question. Yesterday done one question now. Now I'll come to the one more question. Yesterday whatever the conclusions you have studied, I don't know how many are done it, how many are written that conclusions once again. If you are written, well and good. Now the same conclusions also required for remaining questions, any beam. Written for the simply supported beam as shown in the figure. Simply supported beam as shown in the figure. Simply supported beam, for the simply support beam as shown in the figure. Determine maximum shear force and maximum bending moment. And when you are solving the question in your notebook now, below the beam leave the some space. Even though some questions we can complete it without SFD BMD. But after completion of the question, still draw the SFD BMD. Some questions not required, without SFD BMD can complete it. But for your practice, always for every question, draw the SFD BMDs, so that you are going to become perfect in drawing the SFD BMD within a less time. and all that conclusions once uploaded, please make a copy of on your own. If you are going to write down once again on your own, then at least if you write down, you are going to what is that one, and you will get a doubt instead of going through that now, keeping it what now in front of laptop and what of mobile phone. Please make a copy on your own. Then when you are writing, you will understand it now, because everything I am going to discuss now. So instead of writing on your own, so if you can, when you are attending the class now, otherwise when you are attending the class now, you have to write down the problem and you have to write down the conclusions. So that conclusions are already with you. Afterwards, when you are practicing, only go through that conclusion page, make a copy of on your own now. Okay. Is a simply supported beam. Always is about now one roller and one hinge. Always a statically determinate one. Always a statically determinate. So now what is the specialty of this now? Yesterday whatever you have taken, it is a unsymmetric loading. Then calculation of reactions compulsory. Unsymmetric loading. But the calculation of reactions can be done by the two methods. One is the actual method, by using sigma V and sigma M equal to 0. And second one is what now? We can use the one shortcut method, just like a bar fixed at both ends. But that method, what the drawback of that method? That is valid only in simply supported beam. Cantilever beam we don't require now. Directly cantilever beam will get the reactions. We are dealing with only three beams now. Simply supported, cantilever, overhanging. Cantilever beam we don't need directly what you are written now. Vertical reaction equal to minus of sigma V. Horizontal reaction equal to minus of sigma H. And moment reaction equal to minus of net moment at the fixed end. Only one vertical, one horizontal, one moment reaction. Directly you can get it now. Only we need the calculation of reaction simply supported beam and overhanging beam. So that sigma V equal to 0, sigma M equal to 0, you can use it any beam. But yesterday whatever the shortcut method is given now, that is valid only in simply support beam. It is not valid in the overhanging beams. But this is symmetric loading. Symmetric loading. In this case, calculation of reaction is optional. Directly can tell it now. What the conclusion you studied now? Under symmetric loading, reactions are equal and half of the total load. Under symmetric loading, reactions are equal and half of the total load, and the direction of the vertical reaction equal to opposite to the direction of net vertical load. Opposite to the direction of net vertical load. Opposite to the direction of net vertical load. So what the total load? The 4W downward. Total load 4W downward. So reaction should be half of the total load, that is 2W. Therefore reaction should be upward, should be there now. For every question, don't go for the calculation of reaction. Some questions directly can give it now. But what the condition for symmetric loading now? When a beam is said to be under symmetric loading, when a beam is said to be a symmetric loading, conditions are three. If a beam should be under symmetric loading, what the first condition now? Same magnitude of the load. Magnitude of the load, direction of the load, and distance should be same from both the supports. That is, same magnitude of the load should act at the same distance and in the same direction from both the supports. From A, at a distance of L, a load of W is acting downward. Same thing here also what now? Same magnitude, same distance. And direction. If any of these are not satisfied, it is not a symmetric loading. By chance the W upward, it is not a symmetric loading. And by chance the L by 2 is not a symmetric loading. By chance the 2W is not symmetric loading. Symmetric loading means a beam is said to be under symmetric loading when same magnitude of the load is acting in the same direction and at the same distance from both the supports. Same magnitude should be there, direction of the load and distance should be same from both the supports. By chance the W is upward. By chance the W is upward. Yesterday whatever you studied, what now? W, 2W, 3W, it is unsymmetric loading. Then calculation of reactions are compulsory. Here also by chance W is upward, it is unsymmetric loading. Then calculation of reactions are compulsory. Either you can use the actual method or you can use the shortcut method. Therefore directly the reactions are 2W, 2W. Now can you draw the SFD now? I'm starting from the left side. Left hand side upward is positive. W. Sorry. This A should be here. 2W. Upward is positive and downward is negative. Negative. Next, once again draw a parallel line till the next load. Here only what the conclusion you have studied now. When there is no distributed load between two constant point loads. When there is no distributed load between two constant point loads, always the shear force remains constant. Then SFD consists of a horizontal line. SFD consists of a horizontal line. Then BMD consists of an inclined line. Then downward is a negative once again. No, W minus 2W. Next. Upward, once again negative. Minus W and minus W. Then draw a parallel line. Then upward will be a positive. Minus 2W plus 2W. It is a 0. So this is the first cross check now. Almost the same question, but only what is the difference now? Here calculation of reactions are optional. Directly you can tell it. That is under symmetric loading, the reactions are equal and half of the total load, and their direction should be opposite to the net vertical load. So now shear force is changing at only one cross section. There is no distributed load. What the conclusion you have studied now? In the absence of distributed loads, so not slight correction. In the absence of bending couples, what the other name now? Concentrated moments. Bending couple and constant moments are same. Sometimes they are in the bending couple, sometimes they are in the constant moments. Most of the textbook they are in the concentrated moments. Sometime examination they are giving the concentrated moment in place of the constant moment, they are in the bending couples they are using. In the absence of bending couple, what is the first conclusion now? If shear force changes its sign at only one cross section, so shear force changing at only one cross section, so directly where the bend moment is going to be maximum. Bend moment is maximum. So if we ask what is the maximum shear force? No, 2W. Plus W plus 2W or minus 2W, both. It is the plus 2W, is the minus 2W. So if you ask the question, what now? maximum shear forces. So where the direct shear stress is maximum, no? Direct shear stress maximum where the shear force is maximum. So which cross sections are critical? A and E. When you are going for the maximum shear, we are not done the still shear stress in the beam, you are not done it. No? So when you want to do the maximum shear stress calculation, we need a maximum shear force. So what the maximum shear force? No, 2W. And where you are getting that now? At the cross section at the extreme left side and extreme right side. Extreme left side and extreme right side. And you can also call the B and D also. Critical cross sections are any cross section between A and B. Any cross section between A and B. Any cross section between D and E. D to E shear force is same. A to B is also same. So which one are the critical cross section with respect to shear force? Any cross section between A and B, any cross section between D and E. Now if you ask the maximum bendment diagram is compulsory or optional? Optional. So directly bendment will be maximum at C. How many ways you can calculate? Now 2 ways. Directly can calculate the bendment. Now one method is what now? Here to calculate the 2 times or 1 time? Only 1 time. I am taking the left side. 2W into 2L, 4WL. W into L, anti-clockwise negative. So what the bendment now? What the first method now? How to find out the bendment at C? Bendment at C. Algebraic sum of the couples and moments. Left side there is no couple, only moment. 2W into 2L. Next, W into L. So it will be 3WL. I am getting a positive. Positive means S. S means sagging. Sir, what is the use of the sagging? So where the bending stress is going to be maximum at which cross section? At C. Now if we ask what is the bending stress? What is the bending stress at the top fiber of the cross section? This is what now? Cross section C. This is the top fiber. But which type of bendment? Now sagging. Sagging means what? At top you are going to get a compressive stress. So if you ask the same question now, what is the maximum bending stress at top fibers? Top fiber cross section at C. How to find out this now? M by Z. I have to take it MC upon Z. Z about section modulus. But what the bendment value now? 4WL. So 3WL. And section modulus, suppose the rectangular cross section, BD square by 6. But shall I take a positive or negative now? Is a sagging. Sagging means top you are going to get a negative. So answer should be what? Minus. So minus 3WL. Suppose the rectangular cross section is used now. So answer will be 18 WL upon BD square. If you ask the same question now, bending stress at the bottom fibers of the cross section at C. So with respect to bendment, which one is the critical cross section? With respect to bendment, which one is the cross section? Critical C. With respect to shear force, which one are the critical cross section? A to B and D to E. But with respect to bendment, which one is the critical cross section? C. So if we ask what the bendings to the bottom fibers at the cross section at C, then answer will be what? Now positive, you have to take it now. I am assuming the cross section at C. Cross section can be seen in the side view. But when you are drawing the SFD, BMD, what a cross section required or not required? Not required. Why no? Loading diagrams are independent of the material and independent of the material and independent of the shape of the cross section and independent of the material. So when you are drawing the SFD, BMD, none of the question they are going to give the material will be given, cross section is given. But when they are required now only for stress calculation. So whenever they ask the stress, they are going to give the cross section, and whenever they ask the deflection, then they will give the material. But as long as we are calculating only shear force and bendment or axial load and twistment, never cross section as well as what a material is given, not required now. So this is the top fiber, is the bottom. This is the cross section at C. Why you consider this cross section here? Because bendment is going to be maximum. Now on this cross section where the bending stress maximum, top and bottom now. So here bending stress compressive or tensile. Sagging case you are going to get a compressive. Bottom you are going to get a now if you ask what is the bending stress inner fiber, what is the bending stress at inner fiber located distance of 10 mm from the neutral axis, then you can use the how many ways you can find out the bending inner fiber now. My by I, because you already got the bendment, my by I or Ey by R, or what the other way you can calculate now, sigma B max into Y by Y max. So some question they are combining the both SFD, BMD and the bending stress calculation. So what this value now? This value how much you are getting now? 18. The compressive or tensile, compressive, and here tensile. Dot means a tensile. But how you have decided this now? Sagging or hogging. Suppose by chance they negative hogging. Hogging means top is going to be a tensile, bottom is going to be a compressive. Default is about a vertical bending. It is a VTSL. VTSL means what now? It is subjected to vertical bending. Vertical bending always which is the neutral axis now? HCA will be the neutral axis. Now, what is the other way of finding out the bendment at C? This is the one method, directly definition. Bendment is equal to algebraic sum of the couples and moment. And what the other way of finding out the bendment at C? You can use here area of SFD. What you have studied yesterday now? Area of SFD will give the difference of the bendment. Here bendment is going to be maximum. Then how to find out now? MC minus MA equal to area of SFD. This is the one method. This method is what now? Always can be used it now. Otherwise what the other way you can find out now. This is the one method to find out the bendment at C. But second method can be used only when SFD is known. Without SFD also you can find out the directly bendment at C. If you ask only bendment at C, directly can find out now. But second method is valid what when SFD is given. Second method to determine yesterday studied what now? From SFD we can find out the bending moment. That the area of SFD will give the difference of the bending moment. But the other one yesterday, using the BMD we can find out the shear force. That is, by using the slope of the bending moment diagram you are going to get a shear force. So what this now you can write down now. I want to get the bending moment at C. So always go from left to right, left to right, left to right. So when I am going from y sir, y left to right, always x coordinate is positive towards the right side. Origin will be on the left side. X coordinate is positive on the right side. So this will be upper limit, this is the lower limit. Therefore always first write down the bending moment upper limit minus lower limit. That is MC minus MA. Equal to area of SFD between A and C. This method becomes simple when this method becomes simple under constant loads. Under constant load, BMD shape will be what now? Either triangle or rectangle or trapezium. But if you go for a UDL and UVL, BMD the parabola will be there now. Whether UDL or UVL under distributed load, shape of the BMD will be a parabola. Then in that case, area of the parabola always unknown. We know the area of triangle, area of rectangle and area of trapezium. Trapezium also can split into rectangle and triangle. So this method is going to be better in case of what now? Concentrated loads. Concentrated point load and concentrated moment. Concentrated moment. And even you can use it in what now? Because we need a SFD. Even in UDL also. So this method, but only in case of UVL. SFD will be a parabola. So this method can be better what now? Under concentrated loads and UDL. Uniformly distributed load. Under uniformly distributed load, SFD is also what a linear variation will be there. But only UVL is what now? In case of UVL, the SFD will be a parabola. SFD will be BMD is always in case of distributed load. In case of distributed load, both UDL and UVL, always BMD will be a parabola. Any distributed load, BMD the parabola will be there. But SFD will be a parabola in case of UVL. Suppose by chance what a UVL question is there. So this method, we cannot use it directly now. Because every day don't know the directly the parabola areas. If you want, you can use it. But you should know the parabola area. How many type parabolas are going to be there now? One will be second order parabola, cubic parabola will be there now. So this method becomes simple. This method becomes simple when you know the area of SFDs. That is when you know the area of we know the areas of rectangle, triangle and trapezium. So this is going to be possible better in what? In case of, I will recommend this method to find out the bending moment at C by using this area under constant load. Constant load means concentrated point load and concentrated moments, as well as UDL, uniformly distributed load. Sir, can I use the UVL? You can use it, but you should know the parabola area. Instead of that, no, then this is a better method there. In case of UVL, we can go for the parabola area. If you know area of the parabola, you can use it. Otherwise, this method is always valid now. What the bending moment now? Algebraic sum of the couples and moments either on the left side or on right side. Now what the bending moment at C? Maximum. What the bending moment at A? 0. Bending moment at A? 0. Simple supports? 0. What the area now? Two rectangles are there now. Two rectangles. If a positive means positive, that is 2W into L. Next. So maximum bending moment equal to, I am getting a positive. Sagging. Positive means sagging. This method becomes simple in presence of concentrated loads and UDL. Sir, why not UVL? UVL case you are going to get a SFD will be a parabola will be there, no, parabola. If you know area of the parabola, you can use it now. Now question is completed. What is asked the question now? Maximum shear force, maximum bending moment are completed. And we also calculate the maximum bending stress also. Bending stress maximum where? Now where bending moment is maximum. Because default beams are prismatic and same material. If nothing is mentioned, we are taking as a prismatic and same material. Under prismatic member, at which cross section the stress is maximum, where the load is maximum. In a prismatic member means what? Throughout the length, dimensions are same. In a prismatic member, axial stress, bending stress, torsional shear stress, direct shear stress, they are maximum where? No? Where the corresponding load is maximum. In a prismatic bar, axial stress maximum where axial load is maximum. Bending stress maximum where bending moment is maximum. Direct shear stress maximum where shear force is maximum. Torsional shear stress maximum where twist moment is maximum. So in a prismatic member, so directly the stress on the cross sections are maximum. At which cross section the load is maximum. Default to the prismatic member. So directly where the bending stress maximum, you have to see the where the bending moment is maximum. Where the bending moment is maximum at C. So directly the what the bending stress on the entire beam. Bending stress on the entire beam is maximum at which cross section at C. So this only what is a critical cross section with respect to bending stress. But on a cross section, stress is defined on a cross section or at a point. At a point on this cross section, how many points are there? Infinite. So but the bending stress maximum at the top and bottom because of rectangular cross section. So if we go for a triangular cross section, it is maximum at the top. Suppose the cross section at T section, the bending stress is going to be maximum at the bottom now. That all you have studied now. So overall, which one are the critical points? On this cross section, which one are the critical points? Top and bottom are critical because I have taken the rectangle centroid is exactly at the mid depth. Now question is completed. Now if you want to draw the BMD, you can draw it now. Question is completed. Maximum shear force and maximum bending moment. So whenever you ask the maximum bending moment, always draw the SFD. Whenever you ask the maximum bending moment, always draw the SFD. But BMD is not compulsory. Whenever you ask the maximum bending moment, always draw the SFD. From the SFD itself, you can decide it now. As long as there is no concentrated moments, bending moment is maximum at a cross section where the shear force is changing sign. Now complete the BMD. Here BMD cannot be drawn similar to ALD. When the BMD can be drawn similar to ALD, BMD can be drawn similar to ALD only when the beam is loaded by concentrated moments. When the beam is loaded by only constant moment means there should not be any constant point load including vertical reaction. As a BMD can be drawn similar to ALD only when the beam is loaded by only concentrated moments or bending couples. Means there should not be any concentrated point load including vertical reaction. So here the concentrated point loads are there, bend moment varies. So we cannot directly can draw it now. Now whenever your bend moment is varying, So better do the sign convention both sides. This should be used when you are considering on the left hand side. This should be used when you are considering on the right hand side. At A, which one is better? No, left side is better. B, left side is better. D, right side is better. E is better on the right side. When you want to find out the bendment at E, better take the right side. D also right side. But B, left side is better. A is also left side is better. But at C, anyone you can take it. Anyone you can take it. Even if you take the left side, 2 constant point loads. Right side also 2 constant point load. What is the meaning of 2 constant point load? 2 moments will be there. Number of moments are equal to number of constant point loads on the left side or right side. Therefore, left side we are getting 2 constant point loads. That means 2 moments will be there now. So what is the bendment directly here? 0. Bendment at the simply supported 0 because there is no bending couple. So at B, what is the bendment now? 2W into L, clockwise, positive. Whenever I wrote now, shear force constant, bendment is varies linear. Next at C. C just now already completed. Now what the value now? Which sign convention better now? Left or right? Anyone you can use it now. I'm using the left side. 2W into 2L, 4WL and W into L. So it will be what now? 3WL. You have to mark this value properly. So by chance you are going to keep it, you are going to get a single straight line. How to decide it now? Here shear force magnitude changing. Shear force magnitude decreasing or increasing now? Here shear force 2W, here shear force W. So when the shear force decreases, slope of the BMD should decrease. When shear force magnitude is decreases, then slope of the BMD should decrease. Slope should decrease. Means this line should go what now? Slope should decrease. So you should get a one more inclined line with a. So I am going to show like this, then slope will be more. Now this slope is going to be less. The slope of this line should be less than this now. Why? Because this shear force is what now? Less than this now. So how to decide it, sir? Shall I put it upward or downward now? Always you have to how to decide it now. Here shear force is going to be less when compared to shear force in AB. So when the shear force magnitude is less, means what? A slope should be less. Shear force equal to dm by dx. Because the slope of this line will give the shear force. Slope of this line will give the shear force. So since the shear force between B and C is less than the shear force at NB, so slope of this line should be less. That's why it should go like this now. Next. What the bendment at D? Better to go for the right side. Bendment at D, better to right side. 2W into L. 2W into L. Anti-clockwise, clockwise, and anti-clockwise. Anti-clockwise is going to be positive. Positive. Here nobody is going to make a mistake. And directly here 0. If anybody want to show the calculation directly, if anybody want to show the bendment calculations, sir, for my reference, I want to show the calculations. What do you do it now? At A, directly 0. I'm starting from A. I'm starting from A. So then use the left side convention. What the left hand side sign convention now? Clockwise positive. At B, better to consider which side? Now left side. 2W into L, clockwise, 2W into L. 2WL. Next C. Is a clockwise, is anti-clockwise. Since you have taken clockwise positive, anti-clockwise negative. Positive means sagging. Always put it like this now. So this will give the bending stress is positive or negative. What, which side you are getting positive or negative. Next, if you ask at D, but you can say which side? No, right side. Then you can vote now. Start from the right side. At D, which one is better now? Right side is better now. At D, right side is better now. So start from the at E. E is 0. Since you are starting from the right side, use the right side convention. What the right hand side convention now? Anti-clockwise is going to be positive. Or you can put it like this. You go from what now? Like this. After C, going for D. At D, better to consider which side? Now right side. Then you can keep a reference now. Right side, what the sign convention? Anti-clockwise is positive. Up to this one, what we are taken left side means this is a sign convention. At D, we are considering on the right side. Then use the right side convention. Put it like this now. Right hand side anti-clockwise is going to be positive. So 2W, right hand side only one constant point, one moment. 2W into L. At E, directly 0. Up to C, I am taking the left side. Use this sign convention. At D, better to go for which side? No, right side. Then use the right side convention. Right side anti-clockwise is positive. Keep it like this, anti-clockwise. Then it comes right side. So that chance of committing the mistakes are going to be less now. And you can complete the question within a less time now. So most of the friends, I know definitely 90% of the friends are interested, because I know I observed what almost I have with you last almost around 15 hours. Almost you have completed the, we are last almost 18 days or like that. So I have seen your interest, even if I taken what now. 3 o'clock, there was no objection. Only 1 or 2 students was objected. That's why I want to take it now. But only still, but I have to take the majority, because some students are going to be there. Some objections are there. Sir, it is not possible for us. It is an inconvenience to us. So that's why I asked, but I have not received any objection from any of the friends. But most of the friends are there. Sir, we are set it up to able to 6 up to 6 o'clock or like that. What is Sinha? Sir, like this, why can't we solve question number 10 in chapter number 3? It is not symmetric loading. Yesterday I done the same question, my dear friend. Question number 10 I have already solved in the class. Question number 10 I have already solved in the class, Mr. Sinha. Probably you have not gone through the yesterday's load. Question number 10 I have already solved in the class. The same question I had done in the class yesterday. So in this now, what the extra conclusions are discussed now. In this case, what the extra conclusions? Only one conclusion is, under symmetric loading, reactions are equal and half of the load, half of the net load, and their direction will be, direction of the reaction will be opposite to the direction of net vertical load. Under symmetric loading, vertical reactions are equal and half of the net vertical load. Under symmetric loading, vertical reactions are equal and half of the net vertical load, and the direction of the vertical reaction is opposite to the direction of the net vertical load. Once I read, under symmetric loading, vertical reactions are equal and equal and half of the net vertical load, and the direction of the vertical reaction should be opposite to the direction of net vertical load. Here, since net vertical load is 4W downward, so reaction should be upward, should be there now. And we have done only one extra calculation, what a bending stress calculation. You have done it now. What is the next question now? Even the inclined load, same concept, you can use it, my dear friend. Triangle area, you will get it. What change you are going to get it now? Sir, if an inclined line there, how to find out the bending? Suppose the SFD is like this. If the SFD is like this, it how many location changing now? Suppose this A, B and C. So directly what the bend moment is maximum here now. Can't find out now. Sir, if an inclined line means what you have to do it now. Now what this area, trapezium. Trapezium area means what? Rectangle and triangle. I don't know what's the which doubt, simple doubt you are asking now. Either SFD, it is changing sign at B. So directly bend moment is maximum at B. Can't find out this area. But the shape now, trapezium. Trapezium you can split into rectangle and triangle. If you know the trapezium area, directly you can take it. Otherwise you can split into rectangle and triangle. Then directly you can go it now. Mr. Rishikesh. Can't you find out the what Rishikesh, what the doubt in this question now? Can't you find out this area? Sir, inclined line is there, how to do it now? Triangle area can't. Do you know or not? Triangle area is known. Read the next question now. BMD for a beam is as shown below. BMD for a beam is as shown below. BMD for a beam is as shown below. Determine shear force at cross sections one at the cross sections 1 and 2 After drawing the SFD BMD, cross check it. How to cross check it now? Using the conclusions, number of vertical lines SFD are equal to, that are not checked it now. Those are what are practicing. They are going to get it out. Sir, whether my SFD BMD is correct or incorrect. How to cross check it now? Use the conclusion. First of all, both they should be closed. Then number of vertical line SFD are equal to number of concentrated point load in the beam, and height of the vertical line SFD equal to magnitude of the concentrated point load, and between two constant point load when there is no distributed load, SFD should consist of a horizontal line. Next, what about the BMD now? Number of vertical and BMD are equal to number of bending couple. In our question there is no bending couple, no vertical lines. Next, number of inclined lines in BMD. Number of inclined lines BMD equal to number of horizontal line in SFD. Number of inclined lines in BMD equal to number of horizontal line in SFD in the absence of bending couples. In the question there is no bending couple. Then you check it. SFD consists of how many inclined horizontal line? SFD consists of 4 horizontal lines. Then BMD is going to consist of 4 inclined lines. 4 inclined lines. Or whenever shear force constant, bendment is going to be very linear. And at the extreme end, if there is no bending couple means or no moment reaction, bendment is 0. So that you can use it now. And whenever shear force changes sign at only one cross section, when shear force changes its sign at only one cross section, bendment should be maximum. So these are the conclusions you have to use it now. These are the conclusions you have to use it for whether your diagrams are correct or incorrect now. This is a question from, similar question is given GATE civil engineering paper now. So here BMD is given. If BMD is given, directly can find out the shear force. Directly what the answer now, which conclusion you have to use it now? Slope of BMD is going to give the shear force. This section is given between A and B. So what the shape of the BMD? Horizontal line. What the slope of horizontal line? 0. That only I studied what now? Whenever a bend is constant, shear force 0. What the slope of horizontal line? 0. Therefore directly here shear force 0. Next, how to find out the slope now? What the slope of an inclined line? y2 minus y1 upon x2 minus x1. 40 minus 10, 30 upon 4, 7.5. Somebody is getting 25. How 25, my dear friend? Somebody is given 25. Manas is given 25. 7.5. dm by dx of AB portion. So what is the slope of the line? Slope of the horizontal line is going to be 0. Because bend is constant. Constant differentiation is 0. Next. Or otherwise, if anybody want to calculate, what you have to do it now? MB minus MA. Always go from left to right. MB minus MA upon XB minus XA. So 10 minus 10, 6, 0. Next, shear force at BB. dm by dx of BC portion. So MC minus MB upon XC minus XB. What the MC? 40. What the MB? 10. This is 4. So it will be 7.5. So what the conclusion here now? Everybody is given correct answer only. Probably Manas is given incorrect now. Remaining all are given correct. Okay. So this equation important now. This equation, what is this equation now? Shear force at any cross section equal to shear force at any cross section equal to slope of the bending diagram at that cross section. So this equation can be interpreted how many ways now? 3 ways you can interpret it now. The equation can be interpreted in 3 ways. What the first interpretation now? Slope of the bending diagram at any cross section is equal to shear force at that cross section. And what the second interpretation? If I know the Bending equation, the first differential of the Bending equation will give the shear force. The Bending, if I know the sometime Bending equation known, now if you differentiate that Bending equation, then you will get the shear force at that cross section. And what the third interpretation now? What the third interpretation you can write down now? F dx equal to dm. F dx equal to dm. Now if we integrate, what you are going to get it now? mb minus ma equal to integration of fxx dx between a and b. So the equation can be interpreted in what? 3 ways. But the first interpretation now, shear force at any cross section is equal to, that only I used it now, slope of the BMD. Means from this one directly can get the, if I know the, when should I use this now? If I know the BMD, directly can get the shear force. Slope of BMD at that cross section. But the second one now, shear force at any cross section equal to first differential of right. Shear force at any cross section equal to first differential of Bending equation. First differential of Bending equation at that cross section. The question is there now. Sometimes we'll write down the shear force and Bending equation now. So if you know the Bending equation, directly you can get the shear force. Based upon this in the workbook, one question, this is a gate mechanical. This was given in what now? Gate civil engineering. In the gate civil engineering, what is given? A BMD is given, us to find out the shear force. Means you have to go for this now. But in gate mechanical paper, Bending equation is given and asked to find out the shear force. Then you differentiate. First differential of the Bending equation at that cross section. And what the third interpretation now? So this can be written as what now? Then if you can integrate it, for the A and B, whenever you are taking a section, what this XX now? XX is what now? Arbitrary cross section. XX is the arbitrary cross section. So whenever you take a section, limits are going to be there. What this A and B? A is the lower limit and B is the upper limit. You have studied now. So what the integration of this now? MB minus MA. That is what now? A is the lower limit, B the upper limit. What the meaning of this now? Difference of the bendment at upper limit minus bendment at the lower limit of the cross section equal to so what this interpretation now? What this third one now? Third one, first integral of the shear force equation. This is what now? If I know the bendment equation, we can get the, if I know the bendment equation, we'll get the shear force. Similarly, if I know the shear force equation, if we can integrate that equation between lower limit and upper limit, always you are going to take a section. When you take a section, we'll write down the limits now. We already studied how to write down the lower and upper limit now. So if we can integrate the shear force equation between the lower limit and upper limit of that particular cross section, you will give the difference of the bendment at upper limit minus bendment at the lower limit. But what the other way can write down? The integration nothing but the area. Integration nothing but the area or area of SFD between A and B. This only I used it yesterday now. So all these are from this only. Mathematics only. They are used now. When you know the SFD, what you got it now? When you know the SFD, we can find out the bendment. That you have done it yesterday. Next, if I know the bendment diagram, we can find out the slope. The slope of the bendment diagram will give the shear force. Just now you have done it now. And if similarly, if I know the bendment equation, if you differentiate the bendment equation, we will get a shear force. So this is the important one now. So sometime bendment equation is given, then you can find out the shear force differentiation. Similarly, if I know the shear force equation, integrate between lower and upper limit, then you will get the difference of the bendment at upper limit minus lower limit. Or otherwise, if I know the SFD, this is what when you have to go for the integration now. If you know the shear force equation, but if I know directly SFD is given now, the area of the SFD will give the what now? Directly will not give the bendment. It will give the difference of the bendment at upper limit minus lower limit. Upper limit means always what now? You have to go from left to right. X is positive on which side? No, right side. Similarly, if a vertical member is given, if a vertical member is given, what about this equation now? dm by dy. If a vertical member is given, this is what a dm by dy will be there now. In that case, y coordinate is what? A positive upward or downward? Now, y coordinate is positive upward. X coordinate is positive towards right side. X coordinate is positive towards right. Y coordinate is positive upward. Then at that time, you have to take the what now? Bottom to top. Bottom to top, you have to take it now. But when horizontal member, always you have to go from left to right. Left to right. But what is the drawback of this equation? The equation valid what now? Even constant loads, constant moments, distributed load, that is UDL and UL, but this is not valid only under UDM. The equation not valid under UDM. I'm not going for the derivation. If anybody want to get how we got it now, the equation is derived in the textbook, but I'm not taking now. But try to remember this now. This is very important now. Only the drawback of the equation, this is not valid in presence of UDM, uniformly distributed moments. How many distributed load you have studied now? UDL, UVL and UDM. Is not valid why means what? That equation is derived with that case only. So the equation not valid under UDM. Yesterday I not written directly explain with an objective what you are done it now. If a BMD is given, how to get the shear force, you have done it. Then if SFD, how to get the bendiment, you have discussed. Right to the next question now. SFD for a beam is as shown below. Here BMD is given, you have calculated the shear force. Now I will go for the what now? SFD is going to be given. Now you have to find out the bendiment. SFD for a beam is as shown below. SFD for a beam is as shown below. SFD for a beam is as shown below. Determine and this everything is also going to be there in the conclusion page now. SFD for a beam is as shown below. Determine maximum bending moment. Determine maximum bending moment. It's also workbook question only. I'm doing with a different numericals. So here, yesterday what I mentioned, whenever SFDs are given, and it asks the maximum bendiment or bendiment, what is the first assumption you have to make it now? There are no bending couples. There are no bending couples. Whenever only SFD is given, you have to assume that on the beam there is no bending couples. Then only these conclusions are valid now. Then only means there is no bending couple on the beam. Then automatically at A also there is no bending couple, means directly bendiment at A is 0 now. Here also A is 0. So remember what, whenever SFDs are given, we have to assume that there are no bending couples. Means at A also there is no bending couple, at E also there is no bending couple. Now this area will give the what? The bendiment at B. But if I want to find out the bendiment at B, I need the bendiment at A. In all the question directly they are going to take the MEA is 0. Some students are asking, sir, why you are taking the bendiment at A is 0? What is the answer now? Because these conclusions are valid when there is no bending couples. That's why we are assuming the what now? SFD is given now. From this one you have to find out the BMD. This area will give the MB minus MA. So I want to find out I will get the only difference of the bendment. But if I want to find out the bendment at B, I should know the bendment at A. But in all the textbook directly they are taking 0. But some students are asking, sir, why you are taking 0, sir? What the answer now? These conclusions, that is what now? In the absence of bending couple, what you have studied now? First conclusion is bendment is maximum at a cross section where shear force changes. Bendment is maximum at a cross section when shear force changes its sign only at one cross section. In the this conclusion is also given there now. You need not write down. If you want, you can write down. Otherwise, you can check it this now. In the absence of bending couples, first conclusion is what now? Bendment becomes maximum at a particular cross section if shear force changes its sign only at that cross section. If shear force changes its sign only at that cross section. Next one. Second one is what now? If shear force changes its sign more than one cross section. If shear force changes its sign at more than one cross section. Now where the bendment is maximum? We cannot directly tell it now. Now you can see it now in this question now. Shear force changing sign at how many location? B, C and D. Now where the bendment is maximum we don't know. Then what I have to do it now? Maximum bendment equal to larger of the bendiments at the cross section where shear force changing sign. So whenever shear force changes its sign at multiple cross section, the maximum bendiment is equal to larger of the bendiment at the cross section where shear force changing sign. So in this case, the maximum bendiment equal to what now? Where the shear force is changing sign at B, C, D. So maximum bendiment we cannot directly tell it now. Then what do you do it now? Maximum bendiment equal to larger of the bendiment at B, bendiment at C and bendiment at D. Larger of the bendiment at B, bendiment at C and bendiment at D. But by chance yesterday's question what you have studied now? Just now your previous question now. We got like this now. Like this you got it now. But your shear force changing at only one section now. So directly your bendiment is maximum now. But in this case we cannot directly get it now. But both the conclusions are valid when now. If the bendiment should maximum at this cross section and here bendiment should maximum either at B or C or D. What the conclusion? There should not be any bending couples. So in the absence of bending couples, what the first conclusion now? When shear force changes its sign at only one cross section, there directly bendiment is maximum now. But when shear force changes its sign at more than one cross section, maximum bendiment is equal to larger of the bendiment values at the cross sections where shear force changing sign. It is changing sign at B, C, D. So larger of the bendiment at B, bendiment at C and bendiment at D. So here you have to find out bendiment at B, bendiment at C and bendiment at D you have to find out now. So now you can start your calculation from A or E. Bendiment at A, 0. Somebody will ask how it is 0. What the answer now? Absence of bending couples on the beam. Then only that conclusion is valid now. Otherwise you cannot do this question now. Otherwise you cannot do it now. Because of absence of bending couple on the beam means here also there is no bending. Directly bendiment is 0. Next, how to find out the bendiment at B? So this area, directly I am writing now. This area, what this area positive? 5 into 1. So from this one what the MB? 5 kilonewton meters. Next, this area MC minus MA, but don't come from this side now, always go from left to right. X is positive on this side now, go from left to right. So MC minus MB, this area, what this area, negative, minus 7 into 1. But what the MC? Minus 7 plus MB. So minus 2. Next, MD minus MC. MD minus MC, what this area, positive, 2 into 2. So MD. Plus 2. Some student vote now, sir, why should I require now? Already got the bend method B, I got it, bend method C, bend method D. But if you want to cross check it now, there is no bending couple on the beam, assumption here made it now. Means here also bend method should be 0, that you also complete it now. But the ME minus MD. Now what the ME value now? Minus 2 plus MD. Now what the maximum bendment now? Maximum bendment is equal to in the beam is equal to larger of where the shear force is changing sign at BCD, B, C and D. So what the larger of the values now? Larger of 5 minus 2 plus 2. Positive means it's going to be a sagging. Positive means it is going to be a sagging. Now from this now you can answer is what a plus 5. Plus 5 will be the answer now. Suppose the inclined line is there, then you can suppose by chance the inclined line. Whenever shear force the inclined line means the UDL will be there. Whenever SFD the horizontal line means what? Whenever SFD the horizontal line means what? Between here which load is there now? Whenever the vertical line means there is a constant point load is there. One constant point load, one constant. So this beam is loaded by how many constant point load now? 5. How many vertical lines are? Sometime this question will be there now. This beam is loaded by what type of loads acting at B, C, D, E? What the answer now? How many vertical line? 1, 2, 3, 4, 5. Means at A there is a constant point load. What the magnitude of this now? 5. At B, what the magnitude now? What the height of this line now? 12. Next, what the magnitude of the constant load at C? 9. What this height now? 9. What this height now? 4. So this beam is loaded by 5 constant point loads. What their magnitude now? At A, height is what? 5. At B, what the height now? 12. At C, what the height now? 9. At D, 4. At E, 2 will be there now. Sir, whether UDL and UVL is there or not. Whenever a shear force, what you have studied now, whenever a shear force is constant means here one constant point load. Between two constant point load, shear force is constant means there is no distributed load. By chance there is an inclined line means what now? By chance shear force varies. If shear force varies means what? There is a distributed load will be there. Either UDL or UVL will be there. As long as what here one constant point load, here one constant point load. I am getting a shear force constant means there is no vertical load between A and B. So this beam is loaded by only how many loads now? 5 constant point loads will be there. The 5 constant point loads. No other load is there. Sir, what about the bending couple? That only what now? Already I mentioned there is no bending couples now. This beam is loaded by only 5 constant point loads. By chance it is a what now? It is an inclined line means between A and B there is a UDL will be there. If it is a parabola then the UVL will be there. In presence of UDL shear force varies linear. In presence of UVL shear force varies parabolic. Now, can you draw the beam for this question now? Can you draw the beam? SFD is given. Can you draw the beam? The beam. At A, which load is there now? A vertical line means what? There is a constant point load. And what the magnitude of this now? 5. So there should be a constant point load. Upward or downward? Is the shear force positive? When shear force is positive on the left side now, upward is a positive. Here shear force is positive means what now? What is the sign convention of shear force now? Shear force is positive on the left hand side upward. Means there is a constant point load acting in the upward direction. Suppose there is a shear force negative here now. Constant point load is the downward. Next, between A and B, shear force constant means there is no vertical load. There is no vertical load. There is no vertical load. And here once again there is a constant point load is there. How much now? What the height of this vertical line? 12. Means there is a constant point load. Downward or upward now? Now you can see now. Here this vertical line is going upward or downward? This vertical line is going upward means direction of the constant point load is upward. But here vertical line is going downward means it should be what this height now? 12. Now here this vertical line is going upward or downward? Upward. Means it should be upward. What the height of this vertical line? Now here once again this vertical line going downward. Downward means is a downward. What this height now? 4. Now here vertical line is going upward means it is the upward. So this is a similar question is asked in the workbook now. Yesterday I have given this now. Now check it the equilibrium or not. Downward how much? 16. Upward is 16. So they'll ask what in the workbook question they ask what now? What the total downward load? What the total downward load means 16. Automatically upward load is 16. Only first one is important. How we are decided this upward now? Here shear force is positive. And the left side or right side? No, left side. Left hand side when the shear force positive. Upward is positive. Left hand side shear force positive. When it is acting in the upward direction. Here is positive means this constant point load should be upward. Then what the next now? Here positive means this line is going upward or downward? Upward. So when vertical line in SFD, when vertical line SFD is going upward means what the direction of constant point load upward. But this line is going downward means a downward. This line is going upward means it should be upward. So when vertical line SFD goes in the upward direction, when vertical line SFD goes upward, the direction of the constant point load is upward when I am going from left to right. Upward means it's going becoming positive now. And if the vertical line goes downward, direction of the constant point load is the downward. It is coming downward, so downward. Here this line is going upward, so upward, downward. That's all. Now can you draw the BMD for this now? Somebody want without that calculation also you can draw it now. Without that calculation also you can do the BMD. Can you complete the BMD now? That method will take the less time. But if you use this method, what you have to do it now? If you don't know that conclusion, area of SFD will give the difference of the bediment. Then you have to do all this calculation. It will take a time taking now. But if you remember that conclusion, that will take the less time. Now, can you draw the BMD now? So here bend is 0. Now at B better to consider which side? Na left side. At C better to consider which side? Na left side or right side, anyone. But D better to right side. Now just now you have done it now. Same question only. Is a symmetric loading or unsymmetric loading now? Is unsymmetric loading. So here bend is 0. At B better to consider left side. 5 into 1 clockwise positive. Next at C, better to consider left side or right side, anyone. I am taking the left side. 5 into 2, 5 into 2, 10. This distance how much? No, 2. 5 into 2, 10, plus 10, and 12 into 1, minus 2, sorry, minus 12. 5 into 2 is plus 10, and 12 into 1, minus 12. 10 minus 12, it is what? A minus 2. Minus 2. Minus 2. Next, at D better to consider which side? Now at D better to consider right side. Here once again bend made is 0. Bend made is 0. At D better to consider which side? Now right side. Then you are taking the right side means use the right side convention. Right side. What the value now? 2 into 1. Anti-clockwise. Anti-clockwise. Positive. So you are going to get a plus 2. Now what the maximum bendment? Now plus 5. Maximum hogging how much? Now minus 2. So check what the previous also you are getting the same values or not? Now same values. But if you are not thorough with the sign convention, you will not get it now. Sign convention very, very important. That only almost 1 week or 10 days back I discussed the sign convention for all the entire workbook. Loads are what? Omni cross section, axial load, shear force, bendment and twistment. For all the loads I discussed the sign convention. Now, maximum bendment means what? A 5. But what the maximum hogging bendment means? What the answer? Now minus 2. So this beam is what? A subjected to sagging or hogging. Whatever that example you have taken till now, now in both the examples what? Now, it is a sagging. But here you are getting a hogging. Is a which beam? Now simply support beam only. Simply supported beam only. But unsymmetric loading. Yesterday whatever you have taken, what the example loads are acting the same direction. But here 2 loads are downward, 1 load is going to be upward. Now what this G and F? Point of contraflexure. Point of contraflexure. Contra means opposite. Flexure means bending. Opposite bending. Left side is the sagging. Left side of G, sagging. Right side of C, hogging. What the sagging you have studied now? This is called the point of contra. Contra means opposite. Flexure means bending. Left side is the sagging or hogging now? Sagging. Means you are going to get the what the shape you are getting now? Concave. Shape you are going to get a concave. And right side what now? Hogging. Hogging means convex upward like this now. So my right hand is representing what? A sagging. Concave upward. This is what now? My left hand is representing convex upward hogging. So this junction is called as what now? Point of contraflexure. So point of contraflexure is the cross section. So what the next? I mean one more new conclusion now. Point of contraflexure is the cross section where bendment is going to be changes its sign. Bendment is changes its sign. But bendment may or may not be 0. At point of contraflexure, bendment may or may not be 0. But in this case, at G, bendment is changing sign and becoming 0 also. Everybody is going to answer them what? At point of contraflexure, bendment is 0. At point of contraflexure, what? A bendment is going to be changes its sign. But bendment is what? May or may not be 0. But all are going to be what? Take the what? A bendment is 0. Sometimes BMD is like this. Yesterday studied at the end of the class, you have done it now. A cantilever beam loaded with only bending couples. The BMD was like this now. Yesterday I had taken one example with a cantilever beam only bending couples where BMD can be drawn similar to ALD. Suppose this is a BMD. A, B, C, D is a BMD. Similar question yesterday at the end of the year studied now. When I explained about the BMD can be drawn similar to ALD when a beam is loaded by only bending couples. That is when there is no constant point load. So what you can call this? A point of contraflexure. Point of contraflexure. Now in what way this diagram is differ here now? G and F point of counterfacture, B and C point of counterfacture. But what the difference now? Here bend moment is 0, but here bend moment is not 0. What the bend moment at B? What the bend moment at B? Minus 2m. What the bend moment at C? Plus 3m. So in both the case, what the similarity at G and F? Here bend moment is changing sign. Left side is sagging, right side is hogging. Similarly at B, left side is sagging, right side is hogging. Then at B and G, try to correlate this now. This B and this G. What the similarity? Here bend moment is changing sign. Here also bend moment is changing sign. But here bend moment is 0. But here is not bend moment is not 0 now. So this is also point of counterfacture. This is also point of counterfacture. So what the point of counterfacture now? Sometimes this is going to be given as a MSQ. At point of counterfacture, bend moment changes sign. MSQ. At point of counterfacture, bend moment changes sign. Shear force changes sign. Bend moment is 0. Bend moment may or may not be 0. What the answer now? At point of counterfacture, 4 statements are given now. At point of counterfacture, with respect to point of counterfacture, which of the following statement is R true? Is R true? First one is what now? Bend moment changes its sign. At point of counterfacture, shear force changes sign. At point of counterfacture, bend moment is 0. Last one is what now? Point of counterfacture, bend moment may or may not be 0. So what the answer now? A and D are correct now. A and D, but most of them are going to take the A and C. So at point of counterfacture, bend moment will change its sign, but bend moment may or may not be 0. Here it is becoming 0, but here it is not 0. It is not 0. So these two are called as what now? Point of counterfactures. I mean the short form of POCF. This is the short form I am using during my lecture. Full form is what now? Point of contraflexure. Contra means opposite. Flexure means bending. Opposite bending. Where bend moment is going to be changes its sign. How many point of counterfactures are there? No, 2. If it is going to take A and E. Now you can check it now. What way A and E are differ from G and F? At A, bend moment is 0, but is not changing sign. At G and F, bend moment is 0, but changing sign. So this A and E are not point of counterfacture. Everybody is going to tell what a bend moment is 0 means what now? This is not a point of counterfacture. Whenever bend moment is 0 is not a point of counterfacture. Bend moment should change sign, but bend moment should change sign. Bend moment may or may not be 0. Definition already 2 times I repeat. Point of counterfacture is the cross section where bend moment changes its sign from sagging to hogging or vice versa. Or the shape of the beam. Shape of the beam after bending. Shape of the beam after bending changes from concave to convex or vice versa. Point of counterfacture means what always can be seen in BMD. Point of counterfacture can be seen in the BMD. may or may not be 0. Now how to find out this location of the point of contrafacture now? How to locate this point of contrafactures now? How to locate? It is changing sign between B and C. How to locate it now? But here bediment is also becoming 0. In this case also becoming 0. Then what do you do it now? Take a section between B and C. Where it is changing sign? G is lies between B and C. So take a section between B and C. Write down the bediment equation and equate to 0. So what is the actual method to find out the point of contrafacture when it is becoming 0? If at point of contrafacture bediment is also becoming 0. At point of contrafacture bediment is also becoming 0. Then how to find out now? What the actual method now? Take a section between B and C. Some students will take between A and B. Where it is changing sign? G lies between B and C. So take a section between B and C at a distance of x. Write down the bediment equation and equate to 0. That's the actual method. Now similarly where this F lies now between C and D. So take a section between C and D. Write down the bediment equation equate to 0. So for point of contrafacture locations, sometimes bediment equations are required. But your bediment equation compulsory or optional. What the other way of finding out a similar triangle? This is a one triangle, this is a one triangle. This is a one triangle, one triangle. Then you can also use the similar triangles. So point of contrafacture. Whenever at a point of contrafacture bediment is becoming 0. If at point of contrafacture bediment is becoming 0, its location can be obtained by two ways. First method is what now? Write down the bediment equation at a cross section where it is changing sign. It is changing sign between B and C. So take a section between B and C, write down the bediment equation equal to 0. So this is one more objective question will be there now. So this BMD will be given us to find out the location of point of contrafacture, or otherwise find out the in this beam point of contrafacture. What the other method now? By using the similar triangles of BMD. By using the similar triangles of BMD. But this similar triangle method is valid only in case of concentrated loads. But if you go for a UDL and UVL, UDL and UVL always bediment varies parabolically, where you cannot use the similar triangles. So when this first method is compulsory, but the first method now write down the bediment equation and equate. So that method is compulsory in case of UDL and UVL. But whenever a concentrated point loads are there, concentrated loads are there, so you can use the similar triangle concept can be used it now. Now I'm in the second method now. Now from this now, location of G. Location of G. This is B. This is phi. C. I'm assuming this distance is x. So this will be 1 minus x. But this method, whatever I am using now, this is valid only under when bediment is varying linearly. Bediment is varying linear. Bediment will vary linear only under constant loads. But UDL and UVL, distributed load never is varies linearly. Always UDL and UVL, it will vary parabolic. So now you can use the similar triangles now. From this triangle, what you can write down now? Phi minus x upon 2 minus 1 minus x. Check it. Is it okay? Means overall what a G is located, what distance? Now they will ask from the supports. So from the left support, what is distance now? Left support, what is distance now? Because you have taken X from the B. So what is distance now? 1.714. Similarly, how to find out the location of F? Location of F. This is 2. So you directly can give it now. Why? These are the identical triangles. Therefore, directly F will be between now. So this similar triangle concept is required or not required? Not required. So to locate F, no method is required. To locate F, no method is required. Why now? Because these two triangles are what? Similar and identical. But in the previous case, they are similar triangle, but they are not identical triangle. But here, they are similar and identical. What is the height of the triangle? 2. This is also 2. So directly F will be what now? Between C and D. What is this total distance now? So directly this distance is what? 1 meter. So no method required. F can be directly can get it because the two similar triangles, two identical triangle. They are the only similar, but they are not identical. So here you have to the similar triangle concept, but here no method required. Directly can give it. Sometime this question will be there now. So here, now what the location of F now? If you ask from this is from right side, 2 meters. This is 1 and this is going to be 1. So if you ask what the question in the objective question, they will ask now, what the location of the point of counterfracture from the left support now? What the answer now? From left support, G is what now? At distance of 1.714. 1.714. And F is what distance from the left support now? Right side is 2. But in the question is asked left side. What the total distance now? 5. So from the right support 2 means left side support is going to be 3 meters. So the point of counterfactures are located at a distance of 1.714 meter from the left support and 3 meter from the left support. From right side support is the 2 meters now. Now I'm also going for the first method. What the first method now? This method is what valid in case of what only when the bend is varying linear, that is in presence of concentrate loads. This method is valid only under constant, but distributed load, this method is not valid. Then you have to go for the first method. What the first method now? Write down the bend equation and equate to 0. Every example we are getting some new conclusion. Every example we are getting one new conclusion. Now, how to find out the G? What the other way now? Take a section between take a section between, because G lies between B and C. Take a section. Now write down the Bendment equation. I am assuming this distance x. Otherwise I will take this. What x can be measured from where? No. Either you can measure from A or you can measure from B. So I am measuring from left. Now anybody, what the limit for x now? This section is taken between B and C. So what the limit for x? X is measured from what now? A. So what the x value at B? This section is valid only for BC portion. Why are taken between B and C? Because G lies between B and C. Now this section, so whatever the shear force and Bendment equations are valid only for BC. Now what the x value at B? 1 meter. What the x value at C? 2 meters. So for this one, the limits are what now? Now can you write down the Bendment equation now? What is the Bendment equation of 5 into x plus 5x? And what about this distance now? 12 into what this distance now? X minus 1. This distance is what now? This is 1. Then what about this distance now? X minus 1. So 12 into x minus 1 equal to 0. Because this total distance I have taken 1, this is already 1, therefore this will be x minus 1. So we equate what you are getting now. So this is the actual method now. But this method is compulsory when now? When Bendment varies parabolic. Here to here Bendment varies parabolic. In that case this method is compulsory. But whenever Bendment varies linear, then this method is optional. So point of contraflexion located at a distance of 1.714 meter from the left side now. Similarly, F. How to get the F? Where the F will lies now? Between C and D. Now take a section between C and D. Now better to consider which side. Now right side is better. Right side only two constant point loads are there. So I am taking this distance x. And this distance how much is now? Once again it is x minus 1. So now this section is valid for CD portion. This section is valid for CD portion or DC portion, you can call it now, because you are taken between D and C. Now what the limit for x now? X is take measure from the right side. So what the x value at D? 1. What the x value at C? 3. This distance is what? 2. So what the x value at D? 1. What the x value at C? 3. So what the limits now? 1 to 3 meters. So here location of so what the limits here now? . Sir, I want to write down the, suppose somebody is going to measure the x from here. Now what are the limits now? 0 to 2. Already I mentioned everything now. Since I taken the x from the right side, extreme right. So here what the value now? X is equal to 1. X is 3. Suppose somebody is going to directly measure the x from here. Now what are the limits now? 0 to 2. Then what the limit for at D now? 0, and here is 2 will be there now. Now can you write down the Benjamin equation now? Right hand side anti-clockwise positive, clockwise negative. So what the Benjamin equation now? Two into x minus 4 into x minus 1 equal to 0. So from where you measure x means from right side the 2 meter, from right side the 2 meters. Use any method, you will get the same answer now. Don't use the point of inflection. Don't use the point of inflection. Only point of contrafacture. I consider simply supported beam loaded by three bending couples. Loaded by three bending couples. Now can I draw the BMD similar to ALD? Sir, we can draw it now. Sir, no, only bending couple. First you have to find out the reactions. After finding out the reactions, if the vertical reactions are 0, then you can draw the BMD can be drawn similar to ALD. Everybody is what now? Sir, only constant moments are there, sir. BMD can be drawn similar to ALD yesterday mentioned, but they will forget about the condition. What I mentioned now? BMD can be drawn similar to ALD when beam is loaded by only constant moments. That is, there should not be any constant point load. Sir, there is no, but you would also find out the reaction. Reaction also what now? Vertical reaction also constant point load. So first find out the vertical reaction. If the vertical reaction becomes 0 means there is no constant point load. Then BMD can be drawn similar to ALD. First step is to what now? Before deciding the shape of SFD BMD, first decide the reactions. Now what are the reactions now? Horizontal reactions are 0, vertical reaction. Now vertical reaction also 0. Why now? What the sum of all these couples now? Clockwise how much now? 10 and 20, 30, anti-clockwise 30. So whenever already sigma V 0, so if the vertical reaction should become 0, if vertical reaction should become 0, what the condition now? Sigma V should be 0 and sigma M should be 0. Sigma V and sigma M. By chance this is going to be 10. By chance this is a 10. Now vertical reactions are not 0. By chance this is a 10. Clockwise how much now? 20. Anti-clockwise 30. Then reactions are not 0 now. So remember what now? Everybody is going to assume when sigma V 0, reactions are 0. If the vertical reaction should be 0, what the condition now? Sigma V and sigma M should be 0. In our example, already sigma V 0 and sigma M is also 0. The vertical reactions are 0. Now BMD can be drawn similar to ALD. When sigma V and sigma M is 0. I mentioned the vertical reactions means obviously there should be two supports are required. Two supports. Means this is not valid in case of cantilever beam. In cantilever beam only one vertical reaction. So that vertical reaction equal to only sigma V equal sigma V now. So this you cannot check it in what a cantilever beam. Cantilever beam only one vertical reaction. Directly vertical reaction equal to minus of sigma V. Only in cantilever beam vertical reaction will become 0 when sigma V 0. Only in cantilever beam. Remaining case what now? So this is need not be what now? only in case of cantilever beams. Only in case of cantilever beam, vertical reaction becomes 0 when only sigma v 0. Because there only one vertical reaction there, but remaining all the beams, what you have studied now, remaining all the beams. What is the specialty of cantilever beam? Only one support now. Remaining all the beam, minimum 2 supports are going to be there now. Minimum 2 supports are going to be there now. But in cantilever beam reactions, I have already written when you are studying the bar fixed at both the ends. Vertical reaction equal to minus of sigma v. Horizontal reaction equal to minus of sigma h. And moment reaction equal to minus of net moment. So this is what now for other beams now, except cantilever beam. But in cantilever beam directly what now? When sigma v 0, vertical reaction 0. But other beam when sigma v 0, vertical reaction may or may not be 0, we cannot tell it now. So in other beams, if the vertical reaction is 0, both the conditions should be satisfied. Sigma v and sigma m. When both these conditions are satisfied, then only the vertical reactions are 0. But if sigma v 0, sigma m is non-zero, then vertical reactions are equal and opposite. When sigma v 0 and sigma m is non-zero, equal and opposite direction. And magnitude of vertical reaction. Magnitude of vertical reaction equal to sigma m upon span. That is the what now? Sum of the moments and sum of the couples. So if you can remember this one, it will take you can save so much of time now. Suppose this sum of the moments, sigma m I'm getting clockwise. Sigma m I'm getting clockwise. Then this reaction should be what now? Should give a moment in an anti-clockwise direction. Suppose I'm getting a sigma m is a clockwise I'm getting. Then reaction should give a moment in which direction? Anti-clockwise. That means it should be left side. Only in case of cantilever beam when vertical sigma V0 directly RV0. Sigma H0 means horizontal reaction 0. If sigma M is 0 means moment reaction 0. But other beams you cannot directly can get it now. That is the specialty of the cantilever beam. Cantilever beam only one support, one vertical reaction, one horizontal, one moment reaction. But remaining all the beam minimum 2 supports are there. So remaining all the beams, vertical reaction should be 0 means what now? Remaining how many beams are there now? 5 beams. This both the conditions should be satisfied. Next, suppose if sigma V0, sigma M is non-zero. I am getting what? A sum of the vertical for 0. Sum of the moments as non-zero. I am getting the sum of the moments is going to be sum of the moments. I am getting a 5 kilonewton meters anti-clockwise. Clockwise I am getting now. I am getting the sum of the moments. I am getting 5 kilonewton meters clockwise I am getting. So what the answer now? Vertical reactions are non-zero and they are equal and opposite. But what the magnitude of the vertical reaction? 5 kilonewton meter, assume the span is 5 meters. Span is 5 meters. What the span or distance between the supports? I am getting sigma m is 5. Span is 5 meters. 5 by 5 is what? A 1. So vertical reactions are 1 and 1. Vertical reactions are 1 and 1. But how to decide the direction now? So what should be the left side reaction? I need a net moment is what? A clockwise. What I written now? Direction of vertical reaction should be in such a way that it should give a moment in a direction opposite direction of net moment. So since I'm getting a net moment is a clockwise, so vertical reaction should be upward or downward. If I put the upward, what happens? It will also give a clockwise. Then vertical reaction should be downward. If the downward means it will give a moment in which direction? Anti-clockwise. So if I'm getting the sigma m is going to be clockwise, then vertical reaction the left side should be downward. Vertical reaction left side downward means right hand should be upward. So we'll take an example now. But this is valid for simply supported or overhang both the beams. Simply supported and overhang. This will save the so much of time now. But this example will come in which case now? This example will come under which case now? This example will come in the first example or second now? This one. So directly vertical reactions are 0. So in this case, what is the conclusion now? Next, SFD will be a line coinciding with 0. Since there is no constant point load, whenever you want to get a shear force, at least one constant point load is required. Now overall there is no constant point load. So what is the SFD? Line coinciding with 0. SFD is the line coinciding with 0. Whenever you want to get a SFD, what is the requirement? At least there should be a one constant point load is required. At least one constant point load. First you have to decide the reaction, then only you can draw the SFD BMD now. First reactions are important. Without doing the reaction, we cannot conclude the shape of the SFD BMD. So shear force is 0. SFD the line coincide 0. In this case, you will get only BMD will be there. No ALD. To get a ALD, at least one axial load is required. To get a torque diagram, at least one twisting couple is required. Similarly, to get a shear force, at least one constant point load is required. So here we are going to get only BMD. Now here BMD can be drawn similar to ALD. Yesterday, no. BMD can be drawn similar to ALD. When BMD can be drawn similar to ALD, when the beam is loaded by only bending couples and there should not be any constant point loads. Now there is no constant point loads. Now BMD can be drawn similar to ALD. I'm starting from the left side. Now one side sign convention is sufficient. One side sign convention is sufficient. We need to put the sign convention both sides when bend mode is varying. But here bend mode is a constant. BMD can be drawn similar to ALD. Mean what the meaning now? We have to draw a parallel line to the longitude axis until next bending couple. Therefore here one side sign convention is sufficient. Either left or right. I'm starting from the left side. You go to the left side sign convention. Now what the bend mode here? No, there is no bending couple. There is no bending couple. So here bend mode is 0. What the next step now? Here bend mode is 0. We have to draw the BMD similar to ALD. So you have to draw a parallel line to the longitude axis until next couple. Where the next couple is there now? B. So here already 0. So till B is a line coincide 0. Till B is a line coincide 0. Whenever you are drawing the ALD, what you have done it now? We have drawn a parallel line until next axial load. But here you have drawn a parallel line until next couple. But here already bend mode is 0. Then draw a parallel line longitude axis until couple. Now there is a positive or negative? Positive. Left side of the clockwise is positive. Next, draw a parallel line until the next couple. Now this is a negative anti-clockwise. Plus 10 minus 30. Now what should I call this C now? Point of contraflexure. Point of contraflexure. Now you can see now bend mode is 0 or non-zero? Non-zero. That only mention now. Bend mode is changing sign, but bend mode is not 0. But all the textbook they are going to mention about a bend mode is 0. Bend mode may or may not be 0. Now you are directly point of contraflexure loan or not? Now where the point of con C. So we don't need the any method here. Now directly bend mode. Which one the point of contraflexure? C. So when that methods are required now, taking a section equated to 0. Here also some students are what now? Sir, I want to write down the bend mode equation equal to 0 now. Here bend mode is not becoming 0. How can you equate it to 0 now? So that method, whatever the method I read now, taking a bend mode equation equated to 0 or similar triangle, that methods are required when bend mode is going to be 0. That methods are required what now? At a point of contraflexure when bend mode is 0. But here what now? Here point of contraflexure, but it is not becoming 0. So here no method required. Directly which one the point of contraflexure? C. Next, draw a parallel line. Now once again the positive clockwise. Minus 20 plus 20, 0. Minus 20 plus 20, 0. So already 0. Therefore here to here is 0. Here how many point of contraflexures are there? No, only one. only one point of contraflexion is there now. So this is possible only when the vertical reaction 0. But why vertical reaction 0 now? Sigma V 0, sigma M is 0. So whenever a beam is loaded by only bending couples, when a simply supported beam or overhanging beam, only bending couples are there, this method is always not valid now. This method is valid when now? When sigma V should be 0 and sigma M should be 0. By chance this is what now? Plus 10. By chance this is a plus 10. Then this question will become under this case now. It's a plus 10. Then what happens now? Sigma V 0, but sigma M is non-zero. Then that question will come under this case now. Then vertical reactions are non-zero. When vertical reactions are non-zero, shear force is non-zero. Then BMD cannot be drawn similar to ALD. BMD cannot be drawn similar to ALD. So what the conclusion now? When simply supported beam and overhanging beams, simply supported beam and overhanging beams, when they are loaded by only bending couples, what the meaning now? Only bending couple means what now? There is no constant point load including vertical reactions. Including what? Means vertical reactions are what now? 0 means sigma V and sigma M is 0 now. In that case, what the first conclusion now? Reactions are 0. Next, SFD the line coincidence 0. BMD can be drawn similar to ALD. BMD can be drawn similar to ALD. Then at the point of contraflexion, bendment is not going to be 0. Bendment is a non-zero, but point of contraflexion, bendment is going to be changes sign. Next. Now what is the shape of this beam? Now which one is the pure bending? Which portion pure bending? What is the meaning of pure bending you have studied now? Pure bending means axial load should be 0, shear force should be 0, twistment is 0, bendment should be a constant. So which portion pure bending? B to C. And not on the ALD, TMD means what? Already ALD and TMD are line cone 0. There is no axial load. There is no axial load. There is no twisting couple. Therefore, ALD and TMD are line coincide with 0. ALD and TMD are the line coinciding with 0. To get a ALD, what at least one axial load is required on the beam. To get a BMD, at least what one bending couple or one constant point load is required. To get a SFD, at least one constant point load is required. And to get a TMD, at least one twisting couple is required. Now, what about the BC portion? Shear force 0, axial load 0, twistment, and bendment is a constant. Therefore, BC portion pure bending. So this will bend in the form of a circular arc. But the sagging or hogging? No, sagging. So what the shape of this portion now? How the shape of the circular arc will be there now? Is a sagging, means you are going to get a concave upwards. So this portion of the beam will bend in the form of a circular arc such that concave is upwards. Next, what about the CD portion? Once again pure bending. Pure bending. Pure bending. Always pure bending case, what the beam will bend in the form of a circular arc. But the hogging. Then what the shape of the beam here now? After applying this is the initial one now. After applying the couple, so this CD portion will bend in the form of a circular arc such that convex upward. Left side you are getting about now? Concave upwards. Right side you are getting convex upward. So here, let's see what happens now. Left side, what the shape of the beam now? This now? Convex upward. And this side concave, this side concave upward and this side convex upward. So it is changing sign now. So this is why that's why it's called a point of contraflexion. But what the shape of the AB? AB is not a pure bending now. Pure bending means what? A bendment should be 0 or non-zero? Non-zero. It should be a constant, non-zero constant. Pure bending means what now? Here to here bendment is once again 0 only, constant only. But it's not pure bending. Pure bending means what now? AB portion what now? Shear force 0, bendment both are 0. Pure bending means what now? Shear force should be 0 and bendment should be a non-zero constant. Pure bending means what now? Shear force should be 0 and bendment should be a non-zero constant. Then only the beam will bend in the form of a circular arc. But here, shear force 0, bendment is 0. And what the shape of this beam now? It will bend in the form of a straight line. Beam will bend in the form of a straight line. How many shape of the beams you are going to get it now? One is a circular arc. That is possible when shear force 0 and bendment is a non-zero constant. But when shear force 0 and bendment is 0, the beam will bend in the form of a straight line. Straight line. All these shapes are required tomorrow when you are studying the deflection of the beam. When shear force non-zero, means whenever shear force non-zero means bendment is what now? Varies. Then in that case the beam will bend in the form of a parabola. So how many shapes are there? No, 3 shapes. Circular arc. When the beam will bend in the form of a circular arc, na, pure bending. That is shear force 0 and bendment is a non-zero constant. Whenever shear force 0, bendment is a constant only. Whenever shear force 0, here to here shear force 0, here to here 0. But here what happens now? Bendment is constant. Here also constant, but it is a 0. But it is a non-zero constant. Non-zero constant. Therefore, pure bending means what now? Shear force should be 0 and bendment should be a non-zero constant. Then the beam will bend in the form of a circular arc. Then that type of bending called as a circular bending. When you are studying the sagging and hogging, I have explained what now? Every surface will bend in the, I have already shown the sagging now. Every surface will bend in the form of a circular arc. Radius of curvature will change now. You are going to get a concentric circles. All the circles of different radius will be there. Circular bending. What is the meaning of circular bending? Sometimes they will ask now, what is the circular bending? When every surface of the beam, how many surfaces are there? Now, top, inner, bottom, like this now. When every surface of the beam will bend in the form of a circular arc. That is possible when shear force 0 and bendment is a non-zero constant. But if shear force 0, bendment is 0, the beam will bend in the form of a straight line. Straight line. Next, when shear force is non-zero, whenever shear force non-zero, bendment is going to be varies. Then the beam will bend in the form of a parabola. Beam will bend in the form of a parabola. So there are 3 type of shapes are going to be there now. And this also you have studied now. When you are studying the bending equation, what you have studied now? R is equal to, what is the radius of curvature now? From the bending equation you have studied this now. M by I equal to sigma by y equal to E by R. By equating A and C, we have equated A and B, B and C, C and A. This is got it by equating A and C. What the first term of bending equation? M by I. What the last term of bending equation? E by R. So by equating M by I equal to E by M by I equal to E by R, you got this now. Now you can check it now. If EA is constant, default beams are prismatic and same material. EA is already constant. Suppose bendment is also constant. Then what happens now? Already EA is constant. Bendment is also constant, non-zero constant. So overall what you are getting now? R radius is constant. For which curve radius of curvature is a constant? Circular arc. Suppose bendment is 0. Something by 0 infinity. For which curve we are going to get a infinity radius? No, straight line. What is the radius of curvature? Infinity. That's why what I mentioned, when shear force 0, bendment is 0, it will bend in the form of a straight line. Suppose the shear force is non-zero, bendment is varies. In all your previous example, what happens now? Shear force non-zero, bendment is varying. So when the bendment is varies, automatically radius of curvature varies. Then the radius of curvature is varying means a parabola. So from this one, what is the conclusion? This is also given in the conclusion page now. When EA is constant, M is constant. Default constant means what now? Non-zero constant only. Then radius of curvature is constant. Then beam will bend in the form of a circular arc. Then if M is 0, R is infinity, then the beam will bend in the form of a straight line. So these are all required when tomorrow when you are going for the deflection of the beam chapter now. Next, when M varies, whenever bendment is varying means shear force non-zero. Shear force non-zero. When M varies, R also varies. R also varies. Then you are going to get a parabolic shape, parabola. So what is the conclusion now? When shear force 0, bendment is non-zero constant. It will bend in the form of a circular arc. When shear force 0, bendment is 0, is a straight line. When shear force non-zero, bendment varies. In all your previous examples, shear force was non-zero. Shear force non-zero, then bendment is varies. Then you are going to get a parabolic shape. So what is the shape of the beam after bending now? Shape of the beam, what you are studying the pure bending case, you are only study the pure bending case. Under pure bending case, the beam will bend in the form of a circular arc. But most of the beams are circular or non-circular. Non-circular will be there now. Because of what? Always beams are loaded by constant point loads. TSL. Whenever a TSL bendment is varies. Whenever a bendment is varies, what happens now? The shape of the beam is going to be what now? Non-circular, parabolic shape. You are going to get it now. So all the beams are subjected to non-circular bending. Circular bending is possible. Circular bending is possible only under pure bending. So many of questions are possible. Sometimes this question is given. What is the shape of the BC and CD? Circular, parabola, straight line, ellipse. What is the answer? No, circular arc. Here what is the shape now? Straight line. Circular arcs. But both have the same circular arc or different now? Different circular arc. Why now? Bendment is different. Circular arc means R is constant. But what the R value now? EI by M. Bendment is different. Therefore, here one circular arc. What the radius of curvature of that circular arc? EI by bendment is how much now? 10. EI by 10 kilonewton meters. And what the radius of curvature of this circular arc? EI by what the bendment here now? EI by 20. So what the radius of curvature here now? Constant. Automatically EA also you have to take it into what? EA also, what the EA units now? Because of this I have taken the 10 kilonewton. It means EA should be kilonewton meter square. This is the kilonewton meter square. Denominator is what now? Kilonewton meter. Then you are going to get a meters. You are going to get it. What the radius of curvature of this now? EI by 20. EI by 20. But what the shape of the circular arc here? Na BC, sagging. Sagging means you are going to get a concave upwards. CD. What the shape of the circular or convex upward? Shape is same, circular arc, both are circular arcs only. But here, what the shape of the circular arc? Concave upwards with a radius of curvature of EI by 10. What the shape of this circular arc? Such that convex is upward. And what the radius of curvature? EI by 20. EI by 20. And what the shape of this now? Here R is cons infinity. Then you are going to get a straight line. These shapes tomorrow I am going to draw it when you are studying about now deflection of the beam. Directly they will ask the shape. Therefore this portion will bend in the form of a straight line. This portion will bend in the form of a straight line. Straight line means radius of curvature infinity. Similarly about now here also you are going to get a straight line. Straight line. What this C is representing, my dear friend? Somebody is what now? Sir, at C bend made 0. What that C is representing? Try to use the basic. These are all about a longitudinal axis. It is not a point now. What this C is represent? This total line is a longitudinal axis. Somebody is what now? Sir, at C bend made 0. What that C is representing is not a point now. C is not a point. The total line is a longitudinal axis. What the longitudinal axis now? Imagine line joining the centroids. So what this C is representing? Cross section now. It is not a point now. What this A is representing? What this A is representing is not a point. What this point is representing? A cross section. Forget about the basics now. This total line is a longitudinal axis. What the longitudinal axis now? Imagine line joining the centroids of each and every cross section. After teaching all the basics, sir, at C bend made is 0, sir, is telling now. What the bend made at C? Larger of these values I have mentioned now. C means what? A cross section, not a point now. How many cross sections are there? Infinite will be there now. What this A? Cross section. Is a total is a longitudinal axis. What is the longitudinal axis now? Imagine line joining the centroids of each and every cross section. This total cross section represented by point A. I have shown the 3D figure. Everything I have shown, and you are asking probably what Mr. Saket or something now. Fule Saket. I don't know what the pronunciation what now. Try to use the basics. Don't forget about the terminology. Longitudinal axis is an imaginary line joining the centroids of each and every cross section. So each and every point of the longitudinal axis represents a cross section. What this A? Cross section on the extreme left side. It is not a point now. Where you can see the shape of the cross section in the side view. For a horizontal member, where you can see the shape of the cross section side view. What the bend made at C? Bend made C means what now? Cross section at C. At the cross section at C, what the bend made value now? Larger of this value now? 20. It is not 0 now. It is not 0. don't forget about the basics. Don't forget about the basics. Don't lose your concepts or basic terminology. We have completed so many things. Now we are getting a doubts like this now. At a point of contraflexion, if bendment becomes 0, in the previous example, bendment is becoming 0. At a point of contraflexion, if bendment becomes 0, then its location can be located by two methods. One is the what now? Section method. Write down the bendment equation equal to 0. That method is compulsory when bendment varies parabolically. Next, what the other method now? By using the similar triangles. That method is required in case of when bendment varies linearly. Bendment varies linearly in case of concentrated loads, but distributed load always varies parabolically. So whenever you want to get it what now? Point of contraflexion under distributed load, both UDL and UVL, you need a bendment equation compulsory. Bendment equation compulsory to determine the point of contraflexion in presence of UDL and UVL. But under concentrated point loads, bendment equation is optional to locate the point of contraflexion. To locate the point of contraflexion. So what the conclusion now? If a beam is loaded by only bending couples such that sum of the bending couples is 0, when a beam is loaded by only bending couples, and sum of that bending couples becomes 0. So what this conclusion example now? When a beam is loaded by only bending couples and sum of that bending couple 0. So what the first conclusion now? Try to what I said now. Probably this conclusion are not given in your conclusion page now. When a simply supported beam and overhanging beams, when a simply supported beam as well as what now? Any beam, even cantilever also. Whenever any beam is loaded by only bending couples, such that the sum of the couples is 0, In that case, what the first conclusion now? SFD the line coincide with 0. Sum of the couples are 0 means loaded by only bending couples, and sum of the couples are 0 means sigma m 0 and already sigma v 0. So SFD the line coincides 0. Next, BMD can be drawn similar to ALD. Then between two bending couples, bending with a constant. Between two bending couple, bendment with a constant. Then that portion of the beam is going to be bent in the form of a circular arc. The portion of the beam between two bending couples is going to be a circular arc. And in this case, if the point of contraflexion exists, directly we can locate it now. Point of contraflexion now. And what the other conclusion is studied now? Shape of the beam you have studied. 3 shapes. What the different shape means? Circular arc, parabola and straight line. Circular arc is possible when shear force is 0 and bendment is a non-zero constant. When shear force 0 and bendment is a non-zero constant, that is a pure bending. In that case, the beam will bend in the form of circular arc. When shear force 0, bendment is also 0. The beam will bend in the form of a straight line. How do you know it means what from the equation? Just done it now. When shear force is non-zero, bendment varies. In that case, the beam will bend in the form of a parabola. So most of the beams are going to be what now? Bend in the form of a parabola. Why now? Beams are always loaded with a transfer shear load. Whenever a transfer shear load, what happens? Shear force non-zero. So whenever a shear force non-zero, bendment is going to be what now? Bendment is going to be varies. When the bendment varies, radius of curvature varies, then the total beam will not be what now? Pure bending. Part of a beam is going to be what now? Pure bending. Most of the beam is going to be subjected to simple bending. Then the beam will bend in the form of a parabolic shape now. Now take the same example, draw the same example, keep this is what a 10 kilonewton meters. In place of 20, this you can keep it as about a 10. Can you do it now? This, whatever the example I am making now, this is very important now. And always after drawing the SFD BMD, use your conclusions. Number of vertical lines, like that what I can check it. In the previous case, BMD consists of how many vertical lines? 3 vertical lines. Height of the vertical line will give the magnitude of the bending couple. But if you want to get a bendiment there, larger value you have to take it now. And that if you refer the low standard textbooks, the point of contraflexion that they are defined like this now. Point of contraflexion is the point where bendiment is going to be changes sign. It is not a point, it is a cross section. That's why what I mentioned now. Point of contraflexion is the cross section where bendiment is going to be changes sign. But most of the low standard textbook, they are using the what a point. Point of contraflexion is a point where bendiment is changes sign. It is not a point, cross section. Point of contraflexion is the cross section where bendiment is going to be changes sign. If I ask this point of contraflexion definition, 100 students now, 90 students they will define like this only. Point of contraflexion, the points are where bendiment is going to be changes sign. Or some students are going to give 10% of students are the point of contraflexion, a point where bendiment is 0, sir. Point of contraflexion, the cross section where bendiment is changes sign, but bendiment may or may not be 0. Previous question, most of them are going to draw correctly, but this question, out of the 100 students now, 70 students they are going to make a mistake in the BMD. If I ask the sum of the students, can you draw the BMD similar to LD? Sir, we can draw it, sir, because it's loaded by only bending couples. But what the condition I mentioned now? BMD can be drawn similar to ALD when a beam is loaded by bending couples, such a way that sum of the couples should be 0. It is loaded by only bending, but some of the couples are not 0. Sigma m is not 0. So this question will come under what now? This example or this example? No, this. What the sum of the clockwise? How much? No, 20. Anti-clockwise what? A 30. Same question only. Previously I had taken this 20. Now in that case, previous example, this one is the example, this condition. In this case, what? A sigma V 0. Sigma m is 0. So whenever any simply supported and overhanging beams, loaded by only bending couples such that if the sum of the couples are 0, then only BMD can be drawn similar to ALD because their vertical reactions are 0. But here BMD cannot be drawn similar to ALD. Vertical reaction 0 or non-zero? Non-zero. So what should be the first step now? What the first step now? Find out the sigma m. What the sigma m? Sigma m means sum of the moments and sum of the couples. Sum of the moments and sum of the couple. But there is no moments. Only couples are there. So what the sum of all these couples now? 20 clockwise and 30 anti-clockwise. So what the sum of all this now? 10 anti-clockwise. Then you keep a reference like this now. For your reference, you can keep it like this. This is only for calculation of reaction. Put it a dotted line. So reactions are not 0. So what the reaction magnitude now? Sigma m. How much now? 10 upon span 10 by 4. Sigma m upon span 10 by 4. So reactions are 2.5. But shall I put it upward or downward now? Both the reactions are non-zero and they are equal and opposite. So what the magnitude of the reaction? 10 by 4, 2.5. But shall I put it upward or downward? What you have studied now? Direction of vertical reaction should be in such a way that it should give a moment in a direction opposite the direction of sigma m. So this reaction should give a moment in this net moment is anti-clockwise. Net moment is anti-clockwise. Therefore reaction should give moment in which direction now? Clockwise. Then I have to put it upward or downward? Upward. Now this will give a moment in which direction? Clockwise. Ten upon 4. So it will be 2.5. So automatically a reaction should be equal and opposite. 2.5 downward. Downward. Some students I want to use the general method, you can use it. For the general method, sigma v equal to 0, sigma m equal to 0. But if you use this one, you can save some time now. How you decide the directions now? Magnitude, how we got it now? Net moment. Net moment is how much now? 10. Net moment means sum of the couples and sum of the moments both now. But here there is no moment because there is no constant point load. For the sum of all these couples now, 10 anti-clockwise. So 10 by 4. 10 by 4 means 2.5. So how to put it? 2.5 upward or downward because this is anti-clockwise. Therefore the reaction should give a clockwise. Then only the beam is equilibrium now. So if these reactions are 0, most of students are going to tell reactions are 0, sir, sigma v 0. If only sigma v 0, reaction need not be 0. In simply supported, only in cantilever beam, what now? If sigma v 0, vertical reaction 0. Remaining what? All other beam. If sigma v 0 means vertical reaction need not be 0. Because remaining all the beam, minimum 2 vertical reactions are there. So vertical reaction 0 means sigma v and sigma m. That is the previous example. When sigma v 0, sigma m is non-zero. Already given, take an example. So once the reactions are complete, you remove this now. This is only for the cal. Suppose by chance this is clockwise. By chance this is clockwise. Suppose this is plus 40. In place of 10, this is plus 40. Suppose this is plus 40. So not plus means what? A clockwise. Either clockwise 40 will be there. In plus of 10 is a 40. So clockwise 10, clockwise 40, 50. And this is anti-clockwise. So 50 minus 30 is how much? 20. 20 clockwise I am going to get it. Therefore net moment will be 20 clockwise. So what the reaction? 20 by 4, 5. Then the reaction should be a downward because net moment I am getting clockwise. So this reaction should be a downward. So once the reactions are complete, you can remove this. Now this is only for to decide the direction of the reactions. Only to decide the direction of the reactions. Now what the shape of the SFD? Here one constant point load, one concentrated point load. Between two concentrated point load, as long as there is no vertical load. Between two constant point load, as long as there is no vertical load. Between two constant point load, which one is the vertical load? There is no UDL, no, UVL. So directly shear force a constant. So what is the shape of the SFD? Rectangle. Between two constant point load, as long as there is no vertical load, SFD is what now? Rectangle will be there. Means shear force a constant. If you want, you can draw it also. All these couples will affect the shear force or bendment calculation. This will affect the bendment calculation. Shear force will not be affected. So what the SFD? SFD is a positive rectangle. What now? SFD can be drawn similar to ALD. When SFD can be drawn similar to ALD, SFD can be drawn similar to ALD in the absence of distributed load. There is no distributed load. There is no distributed load. Therefore, SFD can be drawn similar to ALD. Left hand side upward is positive. How much? 2.5. What is the meaning of similar to ALD? We have to draw a parallel line until next constant point load. Where is the next concentrated point load? E. So draw a parallel line until E. Upward is positive means downward is negative 0. Now BMD cannot be drawn similar to ALD. Here only BMD, most of the students are going to make a mistake. So here bendment will vary or constant. What the shape of this beam now? What the shape of this beam? Circular or non-circular or parabola now? Parabola will be there now. Whenever shear force is what now? Non-zero. Bendment will vary. So what the shape of the BMD will get it now? Shape of the BMD will get it as what now? Inclined lines and vertical line. Whenever a shear force is constant, inclined line, and because this couple, vertical line. So SFD consists of how many horizontal lines are there now? 1. Then it is what now? For BMD should consist of 1 inclined line. When that conclusion valid, when there is no couple. Now here, what the shape of the BMD? How many inclined lines will be there now? Here 1 inclined line. And then 1 couple, 1 vertical line. Once again 1 inclined line, 1 vertical line. So SFD consists of how many inclined lines now? 1, 2, 3, 4 and 3 vertical lines. BMD, sorry, not SFD, BMD. BMD consists of 4 inclined lines. Between A and B 1 inclined line. Between B and C 1 inclined line. 4 inclined lines and 3 vertical lines will be there. So here, but yesterday that's why I clearly mentioned number of horizontal line SFD are equal to number of inclined line BMD when there is no bending couple. No bend, but here bending couples are there. So that conclusion not valid now. So here SFD consists of only 1 horizontal line. But BMD consists of 4 inclined lines. Because these couples, here 1 vertical line, 1 vertical line, 1 vertical. So what the overall shape of the BMD? BMD consists of 4 inclined lines and 3 vertical lines. Now bendment sign convention, both side is better because bendment is varies. Left side clockwise positive, right side anti-clockwise positive. Right side anti-clockwise positive. Now here how many times you need to calculate the bendment? 2 times. Till now you are calculating what now? Only 1 time because there is no couple. But here how many bendments will be there? Now 2. Is a bending couple or bendment? Bending couple. But there are 2 bendments will be there. When B belongs to AB, 1 bendment. When B belongs to BC, 1 bendment. So when you have done the calculation, what you have done it now? We have taken one section AB, one section BC, then you have calculated bendment in AB, BC, then larger value. Otherwise, if you want to use the shortcut method, what you have done it now? First you have neglected this now. What the bendment at B means, what you have done it now? First neglected. If you have neglected, what the value now? 2.5 into 1. If you neglected 2.5 into 1, 2.5. Clockwise you are taking positive. This is also clockwise. So by neglecting how much now? 2.5. And considering how much now? 12.5. So what the larger value now? 12.5. So what the bendment at B? 12.5. Means when B belongs to AB, the bendment is going to be 2.5 sagging. When B belongs to BC, the 12.5. 12.5 sagging. We have to calculate the 2 times. So all of you can see it here now. First neglect it. I'm taking the better to take the left side. 2.5 into 1. Clockwise. Clockwise a positive. This is by neglecting. Now you consider this value now. By neglecting, now you consider this is a clockwise, anti-clockwise. Clockwise is going to be a positive. 2.5 plus 10, 12.5. Now your diagram is correct or incorrect now. Whenever a couple what now, there should be a one vertical line. What should be the height now? 10. So this is a bending or bending couple. But how it is distributed now? When B belongs to AB, 2.5 sagging. When B belongs to BC, 12.5. Next, at C. Once again you have to calculate the 2 times. You neglect it. I'm considering the left side only. So neglect it. If you neglect it, left side what you are getting now? Couple is there or moments are there? One moment is there. So where is the moment? Moment means what? A number of constant point loads. How many constant point loads are left side now? 1. So 1 into this 2.5 into 2. Positive. 12.5. Sorry. 2.5 into 2. 2.5 into 2 is what? A 5. And the one couple is there. What is the bendment now? Sum of the couples and sum of the moments. Left side one moment is there. 2.5 into 2. Positive. It is also positive. Means how much now? 15. By neglecting, how much you are getting now? 15. So you are going to get a 15. How to join it now? Now you consider this value. Consider this is what? A minus 30. So plus 15 minus 30 minus 15. So the diagram will go in the downward direction. What is the height of the vertical line? 30. Now once again the bendiment are what now? The bending couple. What is the bendiment now? How is this distributed now? When C belongs to BC is distributed as 15 sagging. When C belongs to CD is distributed as 15 hogging. 15 hogging. But this is sagging, hogging. Both are going to be sagging only. For AB is also sagging, BC is also sagging. But this is for BC the sagging and CD the hogging. Now at D, better to consider which side? Now right side. E0. E0. At D, better to consider right side. Once again you neglected. If you neglected what now? 2.5 into 1 clockwise. Right hand side anti-clockwise positive, clockwise and negative. So what the value now? 2.5. Shear force constant, linear. Next consider this value. Next consider this value. This is by neglecting, but the positive or negative, once again negative. Because right hand side anti-clockwise positive, clockwise and negative. By neglecting got it, you are getting minus 2.5, minus 2.5. Now consider this now, minus 12.5. Once again, what the height of the line? 10. Now you can see now, it's also clockwise, it's also clockwise. But this is sagging or hogging now? Both is sagging. AB is also sagging, BC is also sagging. But this is also clockwise. But for D is about hogging. CD is also hogging. CD is also hogging. But what about this sagging or hogging? No, both. Sagging, that only I studied about whenever the loads are applied at a junction, we cannot decide the magnitude and direction. Then only you have to calculate 2 times. How to cross check your diagram now? First you have to check the what now? Number of vertical line. How many couples are there? 3 couples. 3 vertical line. 1, 1, 1. Height. What is height now? 10. What is this height now? 30. What is this height now? Should be 10. Next. What the bending B? Larger of the value. What the bending B? 12.5. What the bending C? Both are equal, plus or minus 15. What the bending C? Minus 12.5, minus 12.5. Next, whenever a shear force constant, bending should vary linear. Now I can check it. How many inclined lines are there now? 1, 2, 3, 4. BMD consists of 4 inclined line, but SFD only 1 horizontal line. That only clearly mentioned. Number of horizontal line SFD are equal to number of inclined line BMD when there is no couple. That's why each and every condition is important. But in all the textbook they are going to mention number of horizontal lines in SFD equal to number of inclined lines. That conclusion is valid when there is no couple. That only I mentioned now. Of 15.5 Mr. Suyas. So here only 1 point of contravecture. Only 1 point of contravecture will be there now. 1 point of contravecture. Maximum bending is plus or minus 15, plus or minus 15, and the point of contravecture is exactly the mid span. Point of contravecture is exactly the mid span. And what the shape of the beam? Nowhere you are going to get a circular arc. Complete beam is a parabola. Shape of the beam means don't tell radius of curvature is what radius of curvature is what varies continuously. Radius of curvature means don't tell parabola. Shape is parabola. Radius of curvature is what varies continuously. So what the shape of this total beam now? Completely a parabola you are going to get it now. Parabola. But what the radius of curvature mean? What the answer now? Radius of curvature varies continuously. Here to here bendment is varying continuously. Bendment is increasing. When the bendment is increasing means what now? Radius of curvature is going to be decreased. So here to here what? A parabola with a what now? A parabola with a decreasing radius of curvature. Decreasing radius of curvature. So how many parabolas are going to be there now? 1, 2, 3, 4, 4 parabolas are going to be there now. But what the radius of curvature mean? What the answer now? EI by M. Bendment is varying continuously. Radius of curvature means answer is varies continuously. Parabola means what? Always is a varies continuously. So what the shape of this beam continuously? What the total shape now? The beam will bend in the form of a parabolic shape. Parabola. And what the radius of curvature means? What the answer now? R varies continuously. R varies continuously. Now it is going to mean, sir, between two bending couple bendment is constant, sir. Between two axial load is constant. Between two twisting couple twistment is a constant. Between two constant point load shear force constant when there is no distributed load. Between two constant point load shear force is constant when there is no distributed load. As long as there is no distributed load between two constant point load, shear force is constant. Similarly, what now? Between two bending couples, bendment is a constant if there is no constant point load on the beam. But here constant point loads are there. Bendment is not constant, bendment is varies. Between two constant point loads, shear force a constant when there is no distributed load. In the absence of distributed load between two constant point load, shear force a constant. But similarly between two bending couple, bendment should be a constant. Mean what the conclusion now? There should not be any constant point load on the beam. There should not be any constant point load on the beam. So you are correct. All the inclined lines are parallel. Mr. Swaraj Pandey is constant. No. Why now? Completely what? Now shear force the same constant. Magnitude is same. Shear force same in what? All the slopes should be same now. The slope of this line, slope of this line, slope of this line should be same. Why now? Because shear force constant. So all these inclined lines are parallel only. Whatever your observation is correct. Absolutely true. These inclined lines are parallel. Why they are parallel? Parallel means the slope is same. Why the slope is same now? Because shear force is constant. What the slope of this line? 2.5. What the slope of this line? 2.5. What the slope of this line? 2.5. Shear force is constant. So in this case, BMD consists of all inclined, three inclined, but they are parallel. This is called as a double-sided overhanging beam. Double-sided overhanging beam. Double-sided overhanging beam. Suppose by chance this is a 15 in place of 10. If it is a 15, then what happens now? If by chance a 15, sigma V0, sigma M0 is a 15. Clockwise 15, anti-clockwise. Then what the conclusion? When sigma V0, sigma M0. Otherwise what now? This beam is loaded by only bending couple. When a beam is loaded by only bending couple and this is a 15. In place of 10 is a 15. Then sum of the couples are 0. Whenever, just now I made a conclusion, whenever any beam is loaded by only bending couples and if the sum of the couples are 0, whenever any beam, maybe all, how many beams you have studied now? 6 beams. Whenever any beam loaded by only bending couples and if the sum of the couples is 0, only bending couples and sum of the couples 0. What the first conclusion I studied now? SFD the line coincides 0. BMD can be drawn similar to ALD. And between two bending couples, you are going to get a bend with a constant. Then that portion will be about now pure bending. That is a pure bending. Then you are going to get a circular arc. Suppose it is a 15. What the answer now? This question only their workbook now. What the vertical reaction? Directly 0. Yesterday I given probably question number 6 are like this now. Directly what the vertical reaction? 0. Then what the conclusion now? BMD can be drawn similar to ALD. Now what the bendment between A and C? Constant. What the bendment between A and C? Constant. What the value now? What the bendment at A? 10. So A to C bendment is going to be plus 10. A to C bendment is at plus 10. Next C to E bendment is constant. What the bendment now? Here bendment is what now? Is the bendment or bending couple? Bending couple. Sorry, bending moment. So what the bendment here now? 15. So what the C to E? 15 will be there now. So what the bendment between A and C? Plus 10. And here plus 15 will be there now. Minus 15 will be there. Sorry. Plus 15 will be there now. Here bendment is constant. Why? Because there is no constant pointed. What you have studied now? When a beam is loaded by only bending couple. When a beam is loaded by only bending couples. And some of the couples are 0. First conclusion is what? A vertical reaction 0. Then SFD the line cone 0. And BMD can be drawn similar to ALD. And between two bending couple, bendment is a constant. Therefore, between these two, bendment is a constant. But what that value now? That directly the bendment. So what the bendment between A and C? Plus 10. And what the bendment between C and E? Plus 15. Plus 15 will be there now. Plus 15. And what the shape of this AC portion? Circular arc. Pure bending. And what about this? Here also one more circular arc. And what the radius of curvature of AC? EI by M. That is EI by 10 kilonewton meters. And what the radius of curvature of CE? What the radius of curvature of CE? EI by 15. EI by 15 will be there now. Without directly can tell it now. Yesterday I take a one question, similar question when a cantilever beam you had done it now. Sigma V0, sigma M is no sir. Sigma V0, sigma M is going to be 0. Just I had done a simply support beam. Now this is a overhanging beam. In all this case, what now? Sigma V0 and sigma M is also 0. Then directly what the if I start from the left side, clockwise positive, directly a drop to C. BMD can be drawn directly similar to ALD. Means you draw a parallel line until next couple. Directly couple is what a C. That only what I have given now. Bendment AC plus 10 sagging. Bendment CE plus 15. So what the shape now? What this AC portion? Circular arc. So what the radius of circular arc now? What the radius of curvature of circular arc? EI by 10. What the radius of circular arc? EI by 15. Both are going to be concave or convex now. Both are concave because of sagging. Total beam is a sagging only. But A to C one circular arc with radius of curvature of EI by 10, and what the radius of curvature of this now? EI by 15. Circular arc concave upwards now. But what the shape of the circular arc? How to decide now? See the bendment positive. Here once again here to here what now? So the beam will bend in the form of what? Two circular arcs, but with a different radius of curvature. R is equal to what now? EI by 15. Same question I'm taking now. Only I'm changing the couple magnitudes now. Here sigma V0, sigma M is non-zero. Sigma V0, sigma M is non-zero. So what the reactions non-zero? Reactions are non-zero. So how to find out the reaction now? What the sum of all these couples now? Phi clockwise, anti-clockwise, phi clockwise. and keep that net moment between these two supports now. So what is this reaction now? Downward or upward? Because net is clockwise. So reaction should be give a moment in which direction? And here what the net moment now? In this case net moment is a clockwise, therefore reaction should give a moment in anti-clockwise. But here net moment I am getting clockwise, therefore reaction should give a moment in anti-clock, therefore it should be a downward. Downward. What is this value now? Net moment 5. Span is what? A 2. Everybody is going to take the length now. In the previous case, length and span are equal. Here, what the length of the beam? 4 meters, but span is what? Of 2 meters only. So 5 by 2. 5 by 2 means how much? 2.5. This distance is called as what? A overhang. Here to here what? A span and the overhang. So this reaction will be automatically here reaction will be upward. Most of students they are going to take the what the length of the beam. So you have taken previous length of the beam. I have not written the length of the beam. Reactions are equal to sigma m upon span. Span is the distance between the supports. In the previous case, span and length are equal, but here span and the length are unequal. Total length is 4 meters. Span means only 2 meters. This distance here going to call as what now? Overhang. Now what is the shape of the SFD? Now once again SFD can be drawn similar to ALD because there is no distributed load. So once the reactions are complete, you can remove this now. Once the reactions are complete, you can remove this now. Now SFD can be drawn similar to ALD. I am starting from the left side. Left hand side upward is positive. Left hand side upward is positive. But here what the constant point load? 0. Here you are going to get a shear force or bendment or both. Only bendment. Shear force 0. But here you are getting only shear force because of only constant point load. Here there is no couple now. Here only bendment will be the remaining 3 loads are 0. No axial load, no twistment, no bendment, so no shear force. Only bendment. Experiment to get an axial load, one axial load is required. To get a shear force, one constant point load is required. To get a bendment, one bending couple is required. To get a twistment, one twisting couple. Therefore, here you are going to get only bendment, but here only shear force. So here shear force is 0. So what the next step? Similar to ALD. Similar to ALD means draw a parallel line. Here height is 0. Negative. Then draw a parallel line until next constant point load. This will not affect your shear force calculation. This will affect only bendment. Now directly draw a parallel line. SFD can be drawn similar to ALD when there is no distributed load. That is what now? Draw a parallel line until next constant point load. So downward is what now? Negative. Downward is negative means upward is a positive. 0. And here to here 0. And whenever shear force is constant, here shear force is what? A constant. When shear force constant, what you have studied now? When shear force constant, bendment should become 0. Sorry, shear force constant means bendment about should vary linear now. When bendment is constant, shear force 0. That only I mentioned yesterday. When bendment is constant, shear force there. But when shear force is constant, bendment is not 0. Bendment is very linear. Linear variation will be there now. So now, here what now? Here shear force 0. Bendment is a constant. Bendment is a constant. Now here you have to do the sign convention on both sides. So directly this is the bendiment. This bending coupled with the bendiment. Positive or negative. Sorry, this you have to check it. So plus 10. Then directly what do you do it now? Here to here shear force 0. Whenever shear force 0, bendment should be constant. Here already amateur getting 10. When shear force 0, bendment should be a constant. So directly you should get a horizontal line. When shear force 0, bendment is a constant. So this portion will be in what now? So AB is what now? Pure bending. Circular arc you are going to get it now. Circular arc. Shear force 0, bendment is non-zero constant. It is about a circular arc. Now at C, how many times you have to calculate here now? Remove this now. Once reactions are complete, you can remove this now. Now here how many times you have to calculate? 2 times. Neglect it now. If you neglect it, what the value now? Left hand side one couple is there, plus 10. And what the moment is this? 2.5 into 1. Clockwise positive means anti-clockwise negative. First neglected. So 10 minus 2.5. 10 minus 2.5. 7.5. So whenever shear force is non-zero constant, when shear force is what? A non-zero constant. So bendment should be what? A varies now. But here shear force 0. Here also constant, here also, but it is 0. Bendment is a constant. But when shear force is about a non-zero constant, then it will vary linear. One order higher than an inclined line will be there now. Then you consider this value. Positive 7.5 plus 5, 12.5 will be there now. Next, at D better to what now? Right side is better. Now start from the right side. Start from the right side. Now directly to the bendiment. Bendiment. Anti-clockwise. Right hand side anti-clockwise positive. And whenever shear force is 0, whenever shear force 0, bendiment is a constant. Whenever shear force 0, bendiment is a constant. Now directly can join it here now. Here to here, inclined line will be there now. Now to cross check it, the number of vertical and how many couples are there now? 1, 2, 3. 3 couples, 3 vertical lines, 10. What is this height now? 5, 10. And when shear force 0, bend moment should be a constant. And whenever shear force is constant, here shear force 0, when shear force 0, bend moment is a constant. But when shear force is a constant, then it should vary linear. Now try to correlate now. In the previous case, between A and C, bend moment is a constant, but is not constant now. A to B is constant, but between B and C is not constant now. Because of this constant point load. Between two bending couple, bend moment is not constant. But in the previous case, a constant because there is no constant point load. But here, between A and C, bend moment is not constant because of this constant point load. Always when a couple is at the junction, you have to calculate 2 times, must neglect it. If you neglect it, what the left side value now? Left side what you are getting now? One couple is there plus 10, one moment 2.5 into 2. Left hand side clockwise positive, so plus 10 and 2.5 into 1 minus 10 minus 2.5, 7.5 will be there. Then you consider this now. Sir, shall I take a positive or negative? Previously I have taken left side. Left side what this now? Clockwise positive. Therefore clockwise should be a positive. When you are calculating here now, you are taken on the left side. But the left side sign convention clockwise. So this should be taken as a positive. 7.5 plus 7.5 plus 5, 12.5. That's why what between two bending couples, if the bend moment should be a constant, between two bending couple, bend moment should be a constant. There should not be any constant point load on the beam. But whenever a constant point loads are there, what the bend moment is not constant. So can anybody tell what this shape now? Circular arc. So what the shape of the beam after bending? Circular arc. But this will be a parabola and circular arc. What the shape of the beam now? 2 circular arc and 2 parabolas. Here tier 1 circular arc, here tier 1 parabola and 1 circular arc. But previously what both are circular arcs only. But here because this constant point load, what happens now? Why you are getting this reaction? Because the sigma m is non-zero. Sigma v is 0, but sigma m is non-zero. So since the sigma m is non-zero, you are getting a vertical reaction. Because of this vertical reaction, bend moment is going to be varies. So once the bend moment is varies, then you will not get a circular arc now. So here here's one circular arc. What you can write here now? This shape is what? A circular arc. Circular arc. Parabola means radius of curvature. What you have tried to know? Varies continuously. Shape means a parabola. Radius of curvature means varies continuously because bend moment is varying continuously. Here Circular arc means radius of curvature constant. So what is the radius of curvature? EI by 10. What is the radius of curvature? EI by 10. So both are of the same shape and same radius of curvature. Concave because of sagging. You can see Mr. One of friend Anurag. Sir, I am a private college. But after studying SOM from you, I am gaining confidence to get good mark in SOM in GATE. The confidence level is very, very important now. Your self-confidence will get it if you are going to put your efforts and if you are going to try on your own. Mr. Anurag, you need not be what now? Worry about a private engineering college. You are entered into BTech, that is based on your 12 standard performance, that is about now your state service exam, whatever you are written. Every state will have some engineering service entrance exam will be there now. So that is what now entry into BTech is different. Now, irrespective of whoever is passed from IIT or NIT or private engineering college or deemed university or university colleges, if your concepts are greater, definitely whoever is what joined the MEDC, no institute spend this much of time, no teacher is going to spend now this now. That's why any exam, you check it what any exam for last 25 years, all the toppers, especially mechanical, are what mostly 90% or 80% are going to be mechanical students will be there now. You may be passed from private engineering college, but one of your friend from IIT, he may get a what now? Definitely you will have little bit strong basic, maybe there definitely IIT students are going to be there now. But if you're struggling for 10 hours, you have to struggle for 12 hours now. So finally after exam now, in the GATE, you may get better rank than your IIT student now. All the IIT rankers are not toppers now. All the IIT rankers are not toppers. Some of the private engineering colleges are the toppers, all India first rank they are getting. But IIT rankers or IIT students are what? They are getting the 10th or 12th rank now. You can see the history also. So sometimes I'm not what, if anybody passed out from IIT, I'm not demotivating. Definitely I'm trying to encouraging the private engineering college students now. Even though you are passed out from private engineering college, you have taken a good decision joining the MEDC and you struggle a lot, then definitely there is a chance of getting a better rank than the IIT and NIT student. Better rank is there. Definitely there is a possibility. So many what now? When I joined the MEDC, probably third batch now, one of the student, Mr. Vinay, is from Private Engineering College, Rajasthan. He passed out from Jaipur Private Engineering College. He joined in a talent batch. In the talent batch, at that time, probably first batch, the MEDC started at that year now. 70% of IIT, NIT students are there. When I have taken an introduction on the first day, when generally offline batches, I used to take the introduction, who is passed out from IIT, NIT, what's your last year rank, like that now. Then during the break time, this Mr. Vinay, he came to me now. Sir, in my batch, all our NIT or IIT students are there. Sir, shall I change my batch? Is it possible for me to get a All India first rank? Can I get a success in the GATE examination now? I told him now, don't bother others now. You are about now unique person. Don't compare with others now. They entered into BTech based upon the different exam. Entry into the BTech is different. Now entry into the what now? Entry into the MTech or PSUs, not based upon what now? From which college you are passed out. Even though you are passed out from BTech, from IIT or NIT, Private Engineering College, there is no reservation for any of the students like that now. Whoever is going to be perform excellently on that particular second week of February 2023, who is going to struggle, who is going to do the right action, and who is going to perform, there is a chance of getting what now? Better rank rankers are going to be there now. Top 100 rankers now. Definitely 20 30 students, maybe IIT students are going to be there now. And 60 70 students are going to be private engineering college students are going to be there now. But only private engineering college students, they have to struggle little bit more than the IIT NIT student, because definitely they will have little bit of strong basics are there now. But IIT NIT students, I'm having a strong basics. If they don't do the any action, if also they don't do the right action, they don't practice it now, they don't appear for the test series, they will not get a success now. So sometimes private engineering college students chance of getting a better rank than the IIT and NIT students now. So already one friend is mentioning Mr. Lohit Kumar Yadav, All India First Rank, Private Engineering College, ESC 2017. There are so many are there. So many are there like that now. So this example once again, what based upon this, so many questions are going to be there now. So far in all the questions, load was directly applied on the beam. Now here we are going to take a, for a beam, some brackets are, levers are attached, and loads will be applied at the end of the lever or a bracket. Now a simply supported beam supported the both end by one hinge and one roller. And here one bracket is welded, no, bracket above. One bracket is welded below. One bracket is welded below. Now here one axial load is applied. One axial load is applied. Here one constant point load is applied. One constant point load is applied. Here anybody what now? Which type of load you can call it now? For this EF member, is about now a constant point load, EF member. This total is called as a structure. But what about this AD? AD is a simply supported beam. Now this FE with respect to this structural member, this load is about a constant point load or a TSL. Now for CE member, which type of load now? Eccentric axial compressive load. With CE member, the eccentric axial compressive load. And what this load for the beam now? For this beam is about, if I extend it, it will intersect it now. It is a TSL, constant point load. Next, what about this load now? What about this load? For HG member the compressive load. For GB member the what? A constant point load. But for the beam is which type of load? The eccentric axial load. For this beam, for simply supported beam, for the simply support beam AD, this load is about now eccentric axial compressive load. But for HG member it is a compressive load. For GB member the constant point load. Same thing about now this load for the beam is about a constant point. If I extend it, it will intersect now perpendicular intersecting what you have studied now, TSL or a constant point load. But for EF member once again a constant point load. But CE member is about now eccentric axial load. Read in the question now. Determine maximum axial load, maximum shear force, maximum bending moment in the simply supported beam AD as shown in the figure. Determine maximum axial load, maximum shear force, maximum bending moment in the simply supported beam AD as shown in the figure. AD. Now what should I do it actually now? You have to draw the free body diagram for this. I'm interested in only simply supported beam. Now this load is not applied at the simply supported beam. Its load is applied at end of the bracket. This is called the bracket. Loads are applied at the end of the bracket. So what the actual method now? First you have to draw the free body diagram for HG. Then you have to draw the free body diagram for GB. Then you have to draw the free body diagram for the beam. Similarly, here also first you have to draw the free body diagram for EF, free body diagram for CE, then you have to draw the free body diagram for this now. But this procedure is required when now? This procedure is required if you have the entire structure. But in the question what I have asked now, only beam. Now how to directly draw the free body diagram for the simply support beam? Are you getting now? First method is what? Actual method is what? Now first you draw the free body diagram for HG, then free body diagram for the GB, then you draw the free body diagram for the this AC member now, AC member, that is a simply support beam. Then here you draw the free body diagram for EF, free body diagram for CE, then you draw the free body diagram for CD. But this method is required if you ask the entire structure. But in the question is asked only simply supported beam. Then you would draw the directly free body diagram for the simply support beam. So how to draw the free body diagram for the simply support beam? This load is applied H. Load, I need the effect of this load. Where this bracket is attached to the beam at B. This bracket is attached to the beam at B. Then what do you do it now? Two dummy force concept. When you study the eccentric axial load and eccentric transfer shear load. Into the two dummy forces. Into the two dummy forces such that they are equal and opposite. Always dummy force should be what now? Equal and opposite. And they should be parallel to applied load. Parallel to applied load. Now you can see it now. Which one will form a couple now? This 10 and this 10 will form a couple. This couple is about a bending couple. That only I studied what now? Eccentric axial load equal to one axial load and one bending couple will be there now. So this 10 kilonewton and this 10 kilonewtons will form a couple. Now this couple is in which plane? The vertical plane. Therefore this will become the bending couple. For horizontal member, bending couple in which plane? Vertical plane and horizontal plane. For horizontal member, twisting couple in the profile plane. This is about a bending couple. So we need this distance are required now. One meter, and this is a 1 meter. So what this couple value? 10 into 1. What this distance of 1 is a clockwise, and this will be an axial load. One axial load will be there now. So what the direction of the axial load? Towards right. So at B. So due to this load now, the load applied at the end of the bracket, due to that load at B, that is what now on the beam, how many loads you are getting? One axial load towards right side, one couple, bending couple in clockwise. Similarly here what now? Now here you are into the two dummy force. Always the dummy force should be parallel to applied load. This load is a horizontal, therefore these two are horizontal. Similarly, want to know the effect of this load. If you want to know the effect of the load at C directly, you want to know the effect of the load at C, you introduce the two dummy force such that they are parallel to applied load and they are equal and opposite. Introduce always the dummy force should be parallel to applied load. Here this load is about a horizontal, therefore it should be horizontal. If it's a vertical, this should be vertical. So this 20, this upward 20 and this downward 20 will form a couple. In which plane now? Vertical plane. So here how many loads will be there now? One constant point load upward, one constant point load upward, one couple in clockwise. So now can you draw the free body diagram for this now? But generally in objective examination they are giving the only one bracket. But I have taken about the two brackets I have taken. Either they are giving the horizontal load or vertical load. You can check the workbook now. But I am combining both so that you can do any of the question now. Here it may take a little bit more time, but you can, with this one now you can do any question, you can answer it now, this type of questions now. So this will become an axial load. Towards right, and this couple is clockwise, a bending couple. What is the name for bending couple? Constant moment. What is this magnitude? No, 10. 10. Next, this will be a constant point load upward. Next, what about this 20 and this 20? Once again, clockwise. What is the distance of 0.5? That's all. Once you done it, remaining can. Now this simply support beam loaded by total how many loads now? One axial load towards right, one constant point load upward, and two couples, two bending couples. Now what is the conclusion you can make it now? Now you can also avoid this two dummy forces concept. Want you can use the dummy force, this is the actual winner. This is required when you want to directly draw the free bar diagram for the simply support beam. Now I am making a one conclusion. If you want to avoid this two dummy force, how do you do it now? Now you can see now this load is what now? Horizontal or vertical now? This load is applied in the at the end of the bracket in horizontal direction. When the load is applied in the horizontal direction at the end of the bracket, when the load is applied at the end of the bracket in the horizontal direction, it is equal to one axial load in the same direction. Where the bracket is attached, where the bracket is attached to the beam, this bracket is attached to the beam at B. So the horizontal load applied at the end of the bracket is equal to how many loads at the cross section where bracket is welded or attached now, B. It is equal to how many loads at B? One axial load in the same direction. One axial load in the same direction. By chance that towards left, then you are going to get one axial load towards left. Next, only you have to decide the couple. When a load is applied at the end of the bracket in horizontal direction, it is equal to one axial load and one bending couple. When the load is applied at the end of the bracket in the horizontal direction, equal to one axial load and one bending couple at the cross section where bracket is welded to the beam. Where is welded na B? So it is equal to one axial load. But how to decide the axial load direction? Since the towards right side, the axial load towards right side. One couple. Now only the student has to decide the direction of the couple. This couple will be a clockwise, anti-clockwise, clockwise. What the distance between the one? Now same thing you can see it now. But when a load is applied in the vertical direction at the end of the bracket, when a load is applied in the vertical direction at the end of the bracket, it is equal to one constant point load, one couple. But what the direction of the constant point load? What the direction of the constant point load? Same direction. Is upward or downward? Upward. One couple. Now this will give a couple in clockwise, anti-clockwise, clockwise. I want to get it what I am calculating here now. So what the distance between F and C? 0.5. So 20 into 0.5. Once again a clockwise. This is the actual method. Those who are not thorough, you can use these two dummy forces now. But if you want to still save your time, you want to save your time directly what now? Whenever the loads are applied at the end of the bracket in a horizontal direction, it is equal to one axial load and one bending couple. But what the direction of the axial load? In the same direction. Since towards right side, one axial load towards right side. Now only the student has to decide the couple direction is a clockwise. So by chance that towards left, this will give a couple in anti-clockwise. Next, similarly, when a load is applied at the end of the bracket in the vertical direction, when a load is applied at the end of the bracket in vertical direction, it is equal to one constant point load in the same direction. One constant point load in the same direction. Now one couple will be there, bending couple is there. But what the direction of the bending couple you have to decide it now. So by chance this is a downward, so by chance this load is a downward, it is equal to one constant point load downward. And this will give a moment in which direction? Suppose this load is a downward like this now. So this will give a moment in which direction? Anti-clockwise. So couple will be anti-clockwise direction. Now we can, remaining is what, calculate the reaction. Why I taken roller now? So I taken a hinge, what happens now? It is a statically in because axial load is there. Yesterday what you said, a simply support beam, overhanging beam will become as what now? Statically indeterminate in presence of axial load. That's why I changed it to roller support. By chance the hinge support is a statically indeterminate. So then how to calculate the reaction you have studied now? Afternoon you are going to discuss one example. If a hinge support is there, how to find out the reaction? By using the compatibility equation, change in length should be equal to 0. Now find out the reactions. Here how many reactions now? One vertical. I'm assuming this is upward. Now horizontal reaction 0 or non-zero? Non-zero because their axial load is there. Roller support only one vertical reaction. These are the assumed directions. So by chance if it is a hinge support, then you are going to get a one more horizontal reaction. Now which reaction you can give it now directly? Only one horizontal reaction. So directly this horizontal reaction equal to net axial load. So RAH is equal to 10 by using sigma H is equal to 0. What is the net axial load? 10 towards right side. 10 towards right side. So reaction should be 10 left side. Next, how to find out these two reactions? You can use your general method now. How to find out this RAV and RDV? Now your couples are there, moments are there. Couples are there and constant point loads are there. So better to go for a general method. What is the general method? Now sigma V is equal to 0 and sigma M is equal to 0. But better to calculate what now? First sigma M. So if I want to get the RAV, if I want to get the RAV, take the moment about D. Take the sum of the moments about D. If you take the sum of the moments about D, directly the moment due to this 0, directly will get RAV. How to find out the other reaction? By using sigma V equal to 0. So first by using sigma V is equal to 0. Upward I am taking positive. So RAV plus RDV equal to minus 20. It's a general method, you have to use it. General method. Actually what these directions are incorrect now, because when the load is upward, reaction should be downward, should be there. I taken what assumed initially. If you cannot predict it, you can assume some arbitrary direction. I taken upward, but obviously this is incorrect now. Since the load is upward, means direction should be downward, should be there. After calculation, if I am getting negative, means I am going to change this now. Next, take the sum of the moments. Take the sum of the moments about which point now? Take the algebraic sum of the moments A, B, C, D. You can take about any point. Take the algebraic sum of the moments and the couple about any point. Either you take about A or B or C or D, any point. But better to take it where now? Where unknowns are there. Where unknowns are there, A and D. So better to take it about A or about D. What the advantage now? If you take it about A, the moment due to RAV will be 0. Then directly you will get RDV. Suppose somebody is going to take it about B. What happens now? If you take sum of the moments about B, we are going to get one moment due to RAV, one moment due to RDV. Then you have to solve the two equations. If I take the sum of the moments about B, you are going to get one moment due to RAV, one moment due to RDV. Then you have to solve the two equations. So always better to calculate the some of the moments and some of the couples where unknowns are there, either about A or about D, about A or about D. So I'm taking about A. So this is a clockwise. I'm taking a clockwise with positive. Now this is also clockwise. It is also clockwise, positive. Now this 20 is what anti-clockwise. 20 is what anti-clockwise. What the distance now? 20 into 2. 20 into 2. Now this is what once again this RdV I taken upward. This is also anti-clockwise. Minus RdV into 3. Some question always you have to go for a general method. What is the general method now? Sigma V equal to 0, sigma M. That is the general method. Always you can use it, but some questions are compulsory. Some questions you can use a shortcut method or conclusions now. So from this one, RdV equal to how much is now? Is it minus 20 by 3? Check it. Minus 20. This is for the 20 and minus 40. Minus 20 by 3. That is minus 6.67. Minus 6.67 means assumed direction is incorrect. So RdV should be downward. Then from equation 1, what the RAV? So minus 20. So you are getting minus 13.33. So this also I am getting negative. Means my assumed direction of RAV is also incorrect now. So it should be a downward. So both are incorrect now. Because when the load is upward, reaction should be downward. So you can assume arbitrary direction. If I am getting both are positive, assume direction is correct, both are incorrect means both are negative now. So change the directions now. RA with how much now? 13.33. RDV. RDV is 6.67. 6.67. Now you can draw the ALD. What is the shape of the ALD? ALD consists of two vertical lines. The positive. So directly I am drawing now, already you have done it, all this thing. Plus 10. Then draw a parallel line. So the negative. So here to here axial load is 0. Here to here ALD will be a line coincides 0. Now SFD can be drawn similar to ALD because there is no distributed load. SFD can be drawn similar to ALD because there is no distributed load. I am starting from left side. Left side what now? Upward is positive, but it is a downward, 13.33, downward, negative. 13.33. What the next step? Now draw a parallel line until next constant point load. Where the next constant point load? Now C. So directly draw a parallel line until C. Parallel line. Now upward the positive. Minus 13.33 plus 20 plus 6.67. Draw a parallel line. Now downward is negative. It's becoming 0. This ALD and this is SFD. But only which diagram cannot be drawn? BMD. Now bend mode calculations are compulsory now. At the extreme end, bend mode is 0. I'm taking the left side is what? Clockwise positive. Here how many times you have to calculate? 2 times. Neglected. 13.33 into 1 anti-clockwise. Clockwise positive means anti-clockwise negative. So what the value now? Minus 13.33. Minus 13.33. Kilonewton meters. Next, consider this value now plus 10. Minus 13.33 plus 10. Minus 3.33. What this value now? 3.33. What should be the height now? On vertical line. Now you can D. Now you can start from the right side. Right side anti-clockwise positive. Right side anti-clockwise positive. Here once again, how many times you have to calculate? See, 2 times. First neglected. If you neglect it, neglected what now? RD into 1. Neglected. Is anti-clockwise. Sorry, clockwise. Anti-clockwise positive means clockwise is negative. 6.67 into 1. Minus 6.67. Negative. Now this will be a positive or negative. Once again is a negative. So 6.67 minus 16. We are taking the anti-clockwise. Right hand side anti-clockwise, but this is a clockwise. So it will go is a negative. Minus 16.67. Total beam is the hogging. Total beam is the hogging. Then here tier 1 inclined line. No point of counterfacture. How to cross check your diagrams now? Already ALD is closed. Number of vertical line ALD equal to number of axial load. How many axial load? 2. 2 vertical lines with height is 10, 10. How many constant point load now? 3 constant point. 3 vertical line SFD. 13.33. This is 20 and this 6.67. And BMD, how many vertical lines? 2. 10 and 10. If you use this sign convention, both sides it will take the less time. So finally, what the answer now? What the maximum axial load? 10. What the maximum shear force? What is the maximum shear force? 13.33 minus 13.33 means it will form a couple in anti-clockwise direction. And what the maximum bending minus 16.67, that is hogging. And not discuss any new conclusion. Only new conclusion is what now? When the loads are applied at the end of the bracket. If you want to get the free body diagram, actual method is what? Introduce the two dummy forces that already studied now. Introduce the two dummy forces such that they are equal and opposite and they should be parallel to applied load. But you want to save the time. What you can do it now? When a load is applied at the end of the bracket in horizontal direction, it is equal to one axial load in the same direction and one couple, bending couple. Only the student has to decide the bending couple direction. And when a load is applied in the vertical direction, then it is equal to one constant point load in the same direction. By chance it is downward. So it is equal to one constant point load. Where now? Where the bracket is welded to the beam. Where the bracket is the welded beam. And one couple will be there. So horizontal load is equal to horizontal load at the end of the bracket. It is equal to on the beam one axial load, one bending couple. Vertical load applied at the end of the bracket. It is equal to vertical load applied at the end of the bracket is equal to one constant point load and one bending couple. That bending couple direction you have to decide it. So remaining is what now? Calculation of reactions. Once you know the reactions, remaining is simple. ALD can be drawn directly. SFD can be drawn. Only Bending diagram calculations are required. So you have to use the sign convention both sides now. Now if you use any other method now, if you use that section method, will take the more time now. But in objective examination after a break, I'm going to discuss most of the questions are like this going to be there now, but they will give the only one bracket. Only one bracket, either horizontal load or vertical load is going to be there now. So that questions you are going, but if this is clear now, the workbook question directly can do it now. Sorry my dear friends, slightly I exceeded. Almost 12:30 I mentioned. Almost it is 12:55. 25 because the question was what now? Instead of taking the multiple question, I taken a one question so that you can answer it. But here there is no extra conclusions. Those you have studied the starting dummy, eccentric axial load and eccentric transfer shear load same. You have to introduce the two dummy force such that they are equal and opposite and they should be parallel to applied load. So thank you one and all. We'll take a break now. 1 hour break. We'll start at 1:45. Then we'll have the 3 hour 10 minutes. Now almost simply supported beam overhangs are completed. We'll take some question on cantilever also. Cantilever also we'll discuss. So that you are going to, after break, you are going to discuss the cantilever beam questions. Cantilever beam also there is no change, only reactions. Now if all the conclusions are going to be there now, all the conclusions are same. Only cantilever beam to beam calculation of reactions are changes. Already you have studied the cantilever beam reactions you have studied now. Vertical reaction equal to net constant, the net vertical load. Horizontal reaction equal to net horizontal load. Moment reaction equal to net moment. But some questions we are going to do it now. So most of the conclusions I have gone through, covered it here now. Sir, how at B bending couple is 10? Why not 5? Why not 5? How it is 5, my dear friend? 20 into 0.5. 20 into 0.5, how much, my dear friend? Satyendra Kumar or what? Who is getting doubt now? Mr. Satyendra Kumar, at B. What is your written now? At B, bending couple is 10. Why not 5? This distance you have to take it now. Don't take the 0.5. What the perpendicular moment is what now? What the perpendicular distance between these two? Couple is what now? What the couple definition, my dear friend? Couple is what? A force into perpendicular distance. What the perpendicular distance between these two now? 1 or 0.5? Already I studied bending couple, etc. This force is like this. One force is like this. This is 10. What's the distance between this now? 1. Couple is what? A force into perpendicular distance. So those you don't have the doubt, please you can log off your system. We'll join at 155. Those you are having some doubt, you can stay back. Those you don't have any doubts, you can log off your system because one of your friend is getting a doubt now. So couple is what now? Couple is what? A force into perpendicular distance. How can you take the 0.5? And similarly what? This is upward. Downward. What is the distance between these two now? 0.5, 20. Already I studied bending, couples and etc. Couple is what? A force into perpendicular. These two are what now? Clockwise. Clockwise. 10. It is also clockwise 10. 10 into 1, 20 into 0.5, 10. Horizontal reaction at A. Directly can tell it, no? What is the net axial load on the beam? Only one axial load is there. Net axial load is 10. Reaction is what now? Towards left side should be there by using sigma h equal to 0. So many questions here done it. Bars question here done it. Now what is the net axial load on the beam now? Net axial load is how much? 10 towards right side. 10 towards right side. Therefore reaction should be towards left side. Otherwise you can use your sigma h also 0 now. Sigma h is equal to 0. Even if you use the sigma h equal to 0, net axial load on the beam is 10 towards right side. Therefore reaction should be towards left side. I hope your doubt is clear. Chinmaya Dehuri. Chinmaya Dehuri. I hope horizontal reaction cleared. Horizontal reaction, what? A net axial load. What is the net axial load? 10 towards right side. Therefore reaction should be towards left side. Still any doubts now?